Okay, I think we're all set to go. We are streaming on Facebook, YouTube, Twitch, Twitter, several pages on Facebook, and you are watching the 131st Global Star Party with the theme of the Voyager Effect, and we'll just get started.
Voyager 1 has left the bubble.
Hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and welcome to the 131st Global Star Party, the Voyager Effect. We have an incredible lineup of speakers tonight, including, not myself, but David Levy, Dr. Linda Spilker from the Jet Propulsion Laboratory. She is the project mission scientist for Voyager. Very proud to have her on. We've got David Eicher coming on as well from Astronomy Magazine, and a whole bunch of other speakers that I think you're going to really enjoy. We have a few things that I'd like to bring your attention about. You know, if you haven't kept up with the Voyager missions, if you don't know this, the Voyager spacecraft, both Voyager 1 and 2, left in 1977. When I talk to people about Voyagers and I say, look, do you realize that we have spacecraft that are now in interstellar space, and that they are still being controlled, still being listened to from a team in California? I think a lot of people, the general public, they get really amazed and surprised about that. And when I think about it, I still kind of get stunned by it. Although I keep up with it, I look at the official websites and try to understand what I can from on a pedestrian level of what's going on in the solar system out there in the far reaches. So I think you're going to learn a lot tonight, and we have live chat as well that you can check in with us and ask questions if you'd like. But I'm going to turn this over to David Levy, who will give some commentary and perhaps a poem.
Well, thank you, Scotty, and welcome to the Global Star Party. My favorite Voyager story was when I was talking with Brad Smith. I was interviewing him for the biography I wrote about Clyde Tombaugh decades ago. And he was musing about how he started out as a middle-aged person and he ended it pretty much with his death. He stayed with the mission for decades. He was really, 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 he really loved that mission. My favorite story, other than the one about Brad Smith himself, was the Voyager record, which has been put on as directed by Carl Sagan. And they were trying to decide what music to put on the Voyager record. Of all the music done over the world, throughout the world, what should we put on the Voyager Golden Record? And they really wanted to get some Beatles. But at the time, the Beatles lawyers couldn't get together on it, and so they couldn't. But then somebody said, Carl, why don't we just put the complete works of Bach and be done with it? And Carl looked and said, that would be boasting. Anyway, I have two poems to read to you today. The first one is from Alfred Lord Tennyson, and it's just one stanza from In Memoriam. And I'm going to ask a question as you're listening to this. What is he writing about? And was the day of my delight as pure and perfect as I say? The very source and fount of day is dashed with wandering isles of night. What is he talking about? Anybody?
I think you're going to have to tell us, David.
The very source and fount of day is dashed with wandering isles of night. For someone who has been looking at the sunspots every day since 1963, that's what he's talking about, the sunspots. But for my true poem today, I'm going to quote from Robert Louis Stevenson, who in 1913 wrote a poem for children and called Storybooks. And I think as we can imagine Voyager inching farther and farther from us as we listen to this poem. There in the night where none can spy, all in my hunter's camp I lie, and play at books that I have read, till it is time to go to bed. These are the hills, these are the woods, these are my starry solitudes, and there the river by whose bank the royal lions came to drink. I see the others far away, as if in flight the camp they lay, and I, like to an Indian scout, around their party prowled about. There in the night, where none can spy, all in my hunter's camp I lie, and play at the books that I have read, until it is time to go to bed. So when my nurse comes in for me, home I return across the sea, and go to bed with backward looks at my dear land of storybooks.
Oh,
Thank you. And
I
back
like
to
that.
you.
I like that. David, are you, what would you say is your most favorite and special moment during the launch or the flybys, or, what would you call your most, special moment about Voyager?
I think it's actually working with Brad Smith. Brad was he was the imaging team leader. I like the way he got his team together. He had a habit of having meetings in rooms where there were no chairs and no tables, so nobody could sit. And so his meetings were very short, always very short. And I really liked that. And I liked it. The other thing was the Saturn 500 as they go through, as they do a series of images through the rings. And if any of you want to see that today, look at the opening credits of any episode of Voyager. And as they're doing the theme music and they bring up past the rings, they show exactly the same image. It might be the image itself from Voyager of the rings turning into the particles of ice and dust. But I think that's one of my favorite of the rings.
That's very special.
And the other thing is,
I would agree. Yes, the rings are incredible. Yes.
yeah, and Carl in his Cosmo series described Saturn's rings as exquisite. And I think that is so important to go out with any telescope at all and look at Saturn's rings.
I think it has transformed many, many people, to become lifelong stargazers. And even if you don't become a stargazer, to see Saturn's rings is life-changing. And I have seen people well up with tears after looking at it. And I think a lot of amateur astronomers can, have had similar experiences if they do astronomy outreach work. It is almost unreal when you see it live for the first time. And of course, to see it the way that Voyager did, and the way that Linda Spilker has seen it, I just would like to have been a fly in the room just to see, those reactions and those emotions. And so, thank you, David. Thank you so much.
Thank you.
Our special featured speaker tonight is Dr. Linda Spilker. She came on to the Jet Propulsion Laboratory when she was fresh. I don't even think she was finished with university work at the time, but she, as I recall, had an internship at JPL. Right off the top, she gets joined up with the Voyager team in 1977. So she's right there at the beginning. She meets and works, shoulder to shoulder with, amazing, legendary figures in planetary science. She works there for a dozen years. And then, so she's there for the flybys. She's, as we talked earlier in an interview I did with her at Mission Control at JPL, which was a huge highlight for me. We were talking about Cassini at the time, and the fire hose of information that was coming out of that spacecraft. But I imagine it was at least that with the Voyager mission, because they were doing things that no one had tried before. Certainly guided by the Pioneer spacecraft, but we had not been to the ice giants yet. We had some of the people that solved and continue to solve these problems that might creep up in a space journey like this. It's just amazing that humans can do this. So then she goes on she's on with the Cassini mission for 30 years. She's the project mission scientist there, and she had like 300 scientists reporting to her. So and now to come back as the project mission scientist for Voyager, basically replacing Ed Stone, who had been with Voyager for 50 years, maybe, something like that, or at least at JPL
years.
for that long.
Yeah, 50 years.
So I'm not going to take away all of what you might have to say, Linda, but I do want to say that we're very, very honored to have you with us tonight. If you haven't really explored what you can find about Voyager, and there's tons of information to look at, you need to catch up and get on the NASA Voyager website and look at all that's going on. The Voyager homepage is amazing with all the news and the current status of the spacecraft. Linda and her team are still talking to and listening to the Voyager spacecrafts. And so I just find that's beyond science fiction for me. Okay, so, but Linda, thank you so much for coming on to Global Star Party.
Well, thank you very much, Scott, for having me here today. And what I'm going to do is share with you something that Scott actually termed the Voyager Effect. And that's how, as we look at the Voyager missions, how its studies may have changed humanity. Does that look okay? That screen look okay?
It's
I think
not
you're on
full
your presenter screen
presentation,
again.
but-
The swap displays button up at the top. Yeah.
Okay, yes,
Perfect.
that looks much better. That looks much better to me too. So, okay, let me go ahead and get started again. Thank you, Scott. I'm very happy to be here and to share with you some of my experiences with Voyager, and in particular to point out how Voyager has changed humanity over the course of its mission and still continues flying. It's in its 47th year. Each spacecraft just celebrated their 46th anniversary since launch. And the two Voyager spacecraft, Voyager 2 was launched first in August of 1977, August 20th, and then Voyager 1 was launched second. Voyager 2 is on a slightly slower trajectory, so Voyager 1 quickly overtook Voyager 2, and both launched from Cape Canaveral in Florida. Between 1977 and its launch and 12 years, 1989, there were 6 extraordinary planetary encounters. And these planetary encounters completely altered our view of planetary science in just that single decade. And this opportunity came about because Gary Flandreau found a rare opportunity that once every 176 years, the 4 outer planets lined up in a way that a single spacecraft could visit all 4. And so Voyager actually got started in 1972, building the spacecraft and then launching in 1977. You think about it, isn't that long since we had put a man on the moon, since Neil Armstrong walked on the moon, until we were busy building and then launching the Voyagers. The Voyager 1 trajectory is shown in blue. We flew by Jupiter in 79 and then Saturn in 1980. The red trajectory is for Voyager 2. We flew by Jupiter in 1979 and then 81 by Saturn, 86 was Uranus, and 89 was Neptune. And you can see that Voyager 1's flyby, we flew close to Titan, that bent us north of the ecliptic plane and out of the solar system. And Voyager 2, we flew close to Neptune's moon Triton, that bent us south out of the equatorial plane. What we did for the first time is reveal just how diverse and active these planetary atmospheres were for these outer 4 planets. They're incredible rings. All of them have ring systems, the moons, and also the magnetospheres of these worlds. And in the case of Voyager 2 was the first spacecraft to encounter Uranus and Neptune and remains the only spacecraft that has flown close to these 2 worlds. This shows those 4 planets to scale relative to the Earth. The Earth is at 1 astronomical unit. That's the distance between the Earth and the Sun. And so in just a little over a decade, Voyager expanded our solar neighborhood out to 30 AU at Neptune. Jupiter is the largest planet in our solar system, and the 2, Jupiter and Saturn, are considered gas giants, while Uranus and Neptune are considered ice giants. They have considerably more water than either Jupiter or Saturn. This is the Voyager spacecraft to give you an idea of the scale. That high gain antenna is about 12 feet across. And you can see to the left, out on the boom, there's that black object. It's the radioisotope thermoelectric nuclear generator. The decay of plutonium generates heat. That heat is turned into electricity, which powers the entire spacecraft. On the right, you can see a long boom, and partway out of the boom are some of the fields and particles instruments. And on the boom itself, you can see sort of the copper-colored instrument. That's the infrared spectrometer, the instrument I worked with for my 12 years on Voyager. That scan platform also contained a narrow and wide-angle camera, an ultraviolet spectrometer, and a photopolarimeter. And if you look carefully at Voyager, you'll notice a small golden object. That's the golden record. And as David talked about earlier, that record was the brainchild of Carl Sagan. He proposed to the project that each Voyager carry a golden record with the sights and sounds of Earth and directions on how to find it, how to find the Earth. And so there are greetings in 54 languages, 118 images, 90 minutes of music, including Chuck Berry's Johnny Be Good. And after the Neptune flyby, he actually came to JPL at Carl's invitation and played that song for the Voyager team and all of the people that were there for that final big party. On the cover of the golden record, you can see a diagram that shows you how to get the information off of the record, starting at the outside. And if you get all of the information correctly decoded, your first image should be a circle. Also, if you look at that starburst, those are the locations, and there are little hashes on it, of the pulsars relative to the Earth. And it's basically a map of how to come back and find the Earth, should you find the Voyager spacecraft and want to find us. going to talk a little bit more detail about 5 of the instruments from the Voyager Interstellar mission that are still operating on the Voyager spacecraft. We had to turn off the instruments on the scan platform. We didn't have a lot of targets to image anymore, and they were taking up a lot of power. And as the plutonium decays, power is a very precious resource on Voyager. Have a long magnetometer boom to measure the strength and direction of the magnetic field. A plasma wave subsystem, it's 2 long, about 10-foot long antennas that measure the plasma and radio waves, both at low rates, and then a waveform receiver that receives them at high rate. And once a week, we record a single frame of high rate data, and we record it on our 8-track digital tape recorder. And our 8-track tape recorder on Voyager 1 is still working, still records the data, and about every 6 months, we play it back. Also have a cosmic ray subsystem that measures the high energy electrons, protons, and ions that make up the galactic cosmic rays. A plasma science instrument that measures the plasma, the ions and electrons that are floating near the Voyager spacecraft, making in situ measurements. And a low energy charged particle instrument that measures the ions, electrons, and protons, but just at a slightly lower energy range than the cosmic ray subsystem, and actually has a detector that rotates to 8 different quadrants and provides 360 degrees of a view. There's the IRIS instrument again. I worked with that team for 12 years, and they actually wrote a proposal to the Cassini mission for a new composite infrared spectrometer, basically a new and improved IRIS. And they invited me to join the team as their ring scientist. And so it was really my experience on Voyager that led to becoming part of a Cassini instrument team. And the Voyager photopolarimeter took observations watching as a star would go behind the rings, and as the star winked on and off behind the rings, it would provide exquisite detail down to tens of meters of resolution of the ring systems, in particular of Saturn, Uranus, and Neptune. So those are 2 of my favorite instruments besides the 5 that are currently operating on Voyager. Just want to very quickly highlight some of the discoveries and some of the very beautiful images from Voyager. 2 spacecraft flew by Jupiter in 1979, finding a very active dynamic atmosphere filled with storms and belts and zones and turbulence, and really a very interesting laboratory for atmospheric science. You look at all 4 of these worlds, all you see are the tops of their atmospheres. They're made mostly of hydrogen and helium, but you see also very colorful, beautiful clouds. And on your right, you can see a snapshot of the Great Red Spot. One of the really incredible discoveries from Voyager were active volcanoes on Jupiter's moon Io. And you can see Linda Morabito holding the discovery image. It was actually an optical navigation frame, a frame taken to precisely locate the moon relative to the neighboring stars. So it's overexposed relative to the moon surface itself. And she saw sitting off the edge that bump, which was one of the volcanoes from Io. And we discovered that there were a number of volcanoes going off simultaneously. And if you look at that feature on Io on your right, it kind of looks like a hoof print or something. That's an active volcano going off, a very dynamic, active surface. More volcanoes going off at one time than we have here on the Earth. Then, of course, Jupiter's moon Europa looked completely different from our moon. Our moon is the standard for what we might expect. And yet here we saw a bright, white, icy surface, lightly cratered, heavily fractured. And it was our first hint of a subsurface ocean on a moon in the solar system. And there's a mission, Europa Clipper, planning to launch next year. It's going to be many, many close flybys of Europa to characterize that subsurface ocean and look for possible jets and plumes. Discovery of Jupiter's faint ring, that was just incredible. This long exposure picture, you can see the yellow arrow is indicating the ring. We actually followed up with Voyager 2 and took the picture that you see on the left. And you can see those wiggly white lines. Those are star trails. We held the shutter open long enough to get an exposure to pick up the faint ring. And during that time, the stars slowly moved back and forth as the spacecraft moved slightly from side to side. On to Saturn. Saturn's most iconic feature, of course, is its rings. There were features in Saturn's atmosphere, but it certainly wasn't as dramatic as Jupiter's atmosphere. And then the rings, and looking at the rings, I just remember watching day after day. It was rings within rings within rings, and the structure just got more and more complicated and beautiful as time went on. Subtle color differences indicating slightly different compositions. The rings are mostly made of water ice with particles from about the size of tiny marbles up to house-sized or larger. The outermost narrow ring, the F ring, is shepherded by a pair of moons. You can see that in the lower right-hand corner. And then the dark finger-like spokes discovered by Voyager, which were in Saturn's B ring, dust elevated above the rings. And just an amazing, an incredible find in looking at Saturn and its rings. This is one of my favorite pictures because it shows how in those days we got back the data. And it really was with paper plots. And in this case, it was a long printout of the stellar occultation data. It's a Calcom pen plotter. There's literally a pen moving back and forth as this white paper slowly scrolls out. And you can see the fine structure and waves and details in the rings. And this was part of the data set that I used for my PhD thesis at UCLA. Enceladus, another bright, icy world, reminiscent of Europa in many ways. Lightly cratered, lots of fractures, all of this pointing to a very young surface. Enceladus was in the center of the E ring, and as Cassini discovered, it actually was generated by geysers, active geysers shooting out of the south pole of Enceladus from 4 long fractures, indicating a global subsurface ocean. Cassini flew through these jets, sampled their composition, and lo and behold, the pH and the conditions look right to potentially support life in the subsurface ocean of one of these tiny moons that we now call ocean worlds. So Voyager certainly expanded humanity's view of where you might find life within our own solar system, and it could be in the oceans of some of these icy moons. Titan, about the size of the planet Mercury, had it formed elsewhere, it could have been a planet in its own right, largest moon of Saturn, and it had a very substantial early Earth-like atmosphere, mostly nitrogen, but with some methane and more complex hydrocarbons. And it had a high level of hazes, and so the filters and the instruments we had on Voyager couldn't see through to the surface. And that was one of the science goals for Voyager. So immediately after the Voyager 1 close flyby, a group of scientists got together and proposed a mission that became Cassini, with an orbiter at Saturn carrying a probe named Huygens that successfully landed on the surface of Titan. And we really did then peel back that haze. Uranus, the first ice giant visited by Voyager, Uranus looked very bland. We're looking at its south pole. It was like a giant bullseye facing us as Voyager flew by. If you stretch the image and you look at the one on the right, there was evidence of some haze right at the south pole, but very hard to tease out. Methane gas is giving it its bluish color. And so far, only Voyager has visited Uranus. So we hope to go back with a Uranus orbiter with probe mission, the probe to go into Uranus's atmosphere and to launch that mission sometime in the next decade. The Uranian rings, 9 narrow rings, potentially young, very dark, very different from Saturn's rings. The blue ring profiles on the left are from the Voyager photopolarimeter, and I really love this view. It shows how much detail you can see when you watch that star move behind the rings. And it was just more information I could use for my thesis than to compare the ring systems at these worlds, and also to kind of think about, how do ring systems form around these worlds? They're inside in a region where you can't scoop the material up and form moons, so you get rings, but how long do they last? And how do they interact? And are they good analogies for protoplanetary disks from which you can form planets in a solar system? Uranus has 5 moderately sized moons, but since it was in a bullseye configuration, we could only fly close to 1. Turned out we picked Miranda, the innermost moon, and what an interesting place. It looked like it had been broken apart and put back together. And if you look carefully in the image on the right, you can see there's a cliff that's over 12 miles high, and all of the fracturing and stretching and activity that's happened on the surface of this moon. Uranus and Neptune both have very unusual magnetic fields. The white dashed line is the spin axis. You can see the arrow indicating the direction of rotation of the planet about its north and south poles. And then the red arrow is indicating the direction of the magnetic field, and it's quite offset by a large amount from its spin axis. And most of the other planets in our solar system, that offset is much smaller. Also, you can see a bar magnet representing the location of the center of the strongest part of the magnetic field, and it's offset from the center of the planet, considerably offset in the case of Neptune. So highly irregular offset fields. With Voyager, we just got a single snapshot as we flew through. Neptune, back to a dynamic, active atmosphere with large storms on its surface. On the surface of the atmosphere, we're just looking at a gas. Neptune's rings, you can see the tenuous rings shown here are revealed by Voyager. As Neptune is in the middle, and so I've just cropped it out because it was overexposed to see these very faint rings. And finally, the major moon in the Neptune system, Triton. Triton is about the size of the planet Mercury, Titan-sized, and it's a captured Kuiper belt object. It has a retrograde inclined orbit. It probably scooped up or broke apart the other moons in the Neptune system as it went from probably a very eccentric orbit down to its circular orbit. Has a polar cap of solid nitrogen ice, and those little black streaks are the places, you can see a lot of them where there were active geysers. We could actually see them in some of the Voyager images, some kind of cracks or vents or something going on, frozen ponds of nitrogen. Another very interesting place to go back and explore in more detail. So just to summarize the legacy, there's a lot, 11,000 years of work devoted to the Voyager project through the Neptune encounters. It inspired a generation of scientists, including me, post-Apollo and pre-Mars rovers. And these tiny moons, once pinpoints of light in a telescope, especially for Uranus and Neptune, were revealed to be unique worlds and in some cases, ocean worlds. And so in a single decade, as I'd indicated, we've revolutionized our views of atmospheres, rings, moons, and magnetospheres, as well as significantly expanded our planetary neighborhood. Some of the last pictures taken by Voyager were turning the cameras back around and taking a portrait of our solar system, taken by Voyager 1 on Valentine's Day in 1990, 6 planets, one of which was the Earth, as Carl Sagan called it, the pale blue dot. It's shown there in a sunbeam. It's a sunbeam of refracted light inside the camera. And that pale blue dot, as Carl Sagan would put it, has everyone you've ever known, everyone that's ever lived on this one small, tiny world. So what next? Perhaps the grandest tour of all for Voyager, the Voyager Interstellar Mission. And what this diagram is showing here is the solar ecliptic latitude. Voyager 2 went south, Voyager 1 went north as a function of heliocentric distance in AU. Voyager 2 is at 160 astronomical units, more than 5 times further than when it flew by Neptune. And to give you an idea of this distance, at the speed of light, it takes a signal a little over 22 hours to reach Voyager 1. That's almost a light day. And so if you send a signal up and say hi to Voyager, you have to wait 2 days before you get something back that says, hi, how you doing? And so both of the Voyagers are extremely far away. And outside this boundary between interstellar space and the space governed by our sun is called the heliopause. So we're in a very unique region, the only spacecraft to be exploring in this region of space. This is another view. If you look at the sun as the yellow dot, you can see the orbits of the planets. And you can see sort of a bubble that marks the termination shock. That's one boundary inside the heliosphere. That's where the solar wind goes from supersonic to subsonic. Then there's the heliosheath, finally crossing the heliopause, the boundary into interstellar space. And just want to show you a little bit about, here's the heliosphere in a kitchen sink. If you run the kitchen sink and you have where the water hits, that's the sun. You can see the water is flowing out very rapidly. You can see that's the supersonic solar wind, hits a boundary, the termination shock, slows down until finally you cross the heliopause. You can put some of those boundaries in there that shows where that sort of ring where at first the shock, where the wind, or in this case, the water abruptly slows down, the wind turns and then flows towards the drain, and then you're in interstellar space. And here's a view of it if you want to try it at home, just nice bright light, and you can look at what the solar wind looks like flowing out from the sun. And here are those boundaries now drawn on that kitchen sink view. So Voyager 1 was the first spacecraft to enter interstellar space, and that was in August of 2012. And this is just a summary of some of those surprises. Basically, the takeaway message here, as time grows short, is that a lot of things our models predicted about the interstellar medium didn't turn out to be the case. Solar effects last far past the heliopause. The particle volume was expected to reach a steady state, but it's gone up, if anything. so many unexpected finds that we found with Voyager and continue to find year by year. Well, in the future, long after the power from Voyager is gone, what we're going to find is that in about 40,000 years, Voyager 1 in particular will get within a light year or so of one of the neighboring stars, and somewhat later Voyager 2. And over the next 500,000 years or so, each Voyager will fly relatively close, within a few light years of a neighboring star, and perhaps someone might find the golden record and decipher it and figure out just where we are here on this planet. And once the power is gone and Voyagers are going silently through space, they're going to become our silent ambassadors to the Milky Way, our iconic testaments to human curiosity. And while the future of our species may not be known, these Voyagers will continue to glide forever amongst the stars. And, who knows what else they might find. Here's some of the legacies from Voyager: its scientific and technical achievements with the planetary flybys and now interstellar space. Certainly holds the records for longevity, speed, and distance. Has had a cultural impact with the golden record. And there, Stephen Colbert, on one of his shows, he's dressed in an astronaut suit, is presenting Ed Stone with a NASA medal. And Voyager is a mission as inspiring as Voyager touches many generations. And so, who knows what remains with Voyager. We're hoping to make it to the 50th anniversary in 2027. So who knows what is in store for Voyager, or should I say Voyager? I'd be happy to take any questions.
Okay, there was quite a few remarks here. Let's see. People saying hello, of course. People that have met you, wanted to say hello. But there were questions about the communications between Voyager and us. You mentioned that it takes almost a light day to get that signal. I've heard it, I've read that the power coming back from Voyager is less than what's called an attowatt. Okay, I'd never heard of the term before, but that's a billionth of a watt. And so I don't know what's a good analogy, maybe you know of one, of how to compare that. That's weak of a signal, but it's amazing that we can listen to Voyager.
It is truly amazing. We're to the point with Voyager now where we need the 70 meters, the three largest stations. One is in Canberra in Australia, one is in Madrid in Spain, and one is at Goldstone here, in the United States. And we need those giant dishes to listen to the whisper from space. And that's to pick up 160 bits per second. So the data rate, that includes all the fields and particles information and the engineering data. And when we want to go up to like 1.4 kilobits per second, we have to array now 5 stations, the 70 and 4 additional 34s, because that's the slowest rate we have with which to play back the tape recorder. So it's certainly a whisper from space, and we're just really happy to have. We wish they'd build a few more antennas, and we're looking into, can we use the VLA, for instance? As Voyager gets further away, that's one of the limitations. Less power, the spacecraft is growing colder, and the distance just grows longer, making it more challenging to continue to receive the data.
Question from John Ray watching on Facebook. He says, that was wonderful, thank you. When will the distance be too far to utilize, or will their power be gone by then? Is it a distance thing, or is it a power thing?
Yeah, it'll be very interesting. Or is it just an aging spacecraft components? We're now starting to see evidence of the thrusters slowly clogging. Yeah, we had some backup thrusters we're using, but we're on our final set. Will it be that? Will it be some other problem with just having been out in space for so long, or power? With less power, we're starting to slowly turn off subsystems, eventually instruments, and then things get colder. So it's kind of a race between less power, too cold. And we're hoping perhaps to make it, certainly to the 50th anniversary. That would be great. That's our goal. Can we get one or both Voyagers to the 50th and perhaps into the 2030s? it would be really great to get to 200 AU. Just has
Oh,
a
yeah.
nice ring to it.
A nice milestone. That's great. Wow. Okay. So, what's happening right now with the Voyagers? I read just briefly a headline that one of them was, you know, turned off. Is it completely turned off, or not turned off, but that you weren't communicating with it?
Right. We had a little bit of trouble. A bad command ended up going to Voyager 2, and it pointed off about 2 degrees from its pointing directly at Earth. And you think, oh, 2 degrees. I mean, that's so tiny. But the distance of Voyager 2, that was the equivalent of the Earth-Jupiter distance. So
Okay.
it was not pointing at the Earth. But fortunately, what we did is we used the most power we could get and sent the equivalent of a shout from the station in Australia. And that got in, and it sent it back to its normal position. And everything has worked well with both spacecraft ever since.
Yeah.
But
See,
there were
it's
some scary moments there with that. But fortunately, we were able to command it back, and it would have gone back on its own, in like in another 6 weeks or so. It has a lot of fault protection and automatic algorithms that kick in, if it doesn't hear from us after a certain amount of time. So that would have happened, but it was good to get it back sooner.
Yeah, for sure. Yeah, and it's stories like that just totally amaze me. That that humans are able to build something like that, build these kinds of fail safes in, the redundancy into it, and for people to go, we can do this or we can do that and extend the life of this. And so that's getting that extra life, squeezing out every last drop of performance out of those spacecraft and continuing to do real science. That's just amazing. It really is. It makes my head spin.
It's a real tribute to the flight team who has been, so creative in keeping the spacecraft going for this long, and just their perseverance and, like you say, creativity. And also, as we need it, some of the experts, of course, with time have retired. But if we encounter a problem that might require their expertise, they're really happy to come back and help us and sit down with us and find some solutions to our problems. So that's great too.
Wonderful. And the team that's there, are there a lot of legacy members still part of the team, or has it been replaced by younger scientists? What's it like?
Yeah, it's a mix of each. We have some people that have been there since the instruments were built in 1972. A couple of the heads of the instruments and some of their team members. Some of the flight team has been also on Voyager for decades as well. But we're in the process, and have been for some time, of training up the next generation, bringing on the postdocs and graduate students and early career scientists and engineers to transfer that knowledge and give them a chance to work on Voyager. Somebody says, hey, a chance to work on Voyager, I'll take it.
Yeah.
So that's great.
Absolutely. There was a question about the Voyager 2 being repositioned. Was it done with thrusters or reaction wheels?
Yeah, we don't have reaction wheels like Cassini had. We are really use thrusters to point Voyager. It's a 3-axis spin stabilized spacecraft. We're always pointing at the Earth. We're always sending back data. And we get about 8 hours per day for each spacecraft of data that we get coverage. So if we just downlink all the time, then they can give us these pieces of time in between other missions, and we can collect those data.
Wow. Well, Linda, thank you so much. It was a real privilege, and I know our audience learned new stuff. I learned new stuff, and it's great. And we really, I think I can speak on behalf of all of us. We are very, very excited about what Voyager will bring to us in the future, and at the point of when maybe it does shut down, I hope I'm around to watch it happen. So I wonder what the epitaph might be about Voyager towards its end, but it's still a very active, a live wire out there, and so it's really cool.
Absolutely. Well, it's been a pleasure, Scott. It's been a great
Thank you
pleasure.
so
Thank
much.
you for inviting me. Thank you.
Thank you, Linda. Take care.
You too.
Okay. Well, now that your head might be in the outer solar system and sorry for centers, I'm making like mind blown memes, live memes back there on our Zoom room. So I hope you really enjoyed that. Our next speaker is none other than David Eicher, the editor-in-chief of the world-famous Astronomy magazine. David, thanks for coming on to the program. How many, I don't know if you know this answer, but how many articles do you think that astronomy has written about Voyager through the years?
Oh, many. And the initial coverage was before I got to the magazine, but it was one of the major things, the coverage of Voyager, especially in 1979 through 81, of, the Jupiter and Saturn encounters that really catapulted Astronomy magazine to be the largest magazine on the subject in the world. And it was really Richard Berry and Robert Burnham who were writing about it at that time. I got there in 82, just after that explosive wave of, when I was publishing my little teenage magazine, at the time that Voyager got going. But it was huge for me as well, because the first thing I ever saw through a telescope, it was a Criterion RV6, was Saturn. And I was electrically hooked. I had the Saturn connection, and I got to know Carl Sagan and his involvement with Voyager and others. And it was, it seemed like the doors opened and the exploration of anything out there was possible. It was a supercharged time that Voyager represented in terms of exploring and understanding the universe. So it was really big. But I wasn't at the magazine until the Uranus and Neptune encounters a little bit later on Voyager's timeline. But it was a huge influence that really helped to make the early Astronomy magazine what it became, honestly.
Right. Yeah, and it's not over, right? So
and it's not over.
The story goes on.
It's not, and this was a fantastic thing to have Linda on tonight and a great talk.
Yeah, wonderful. All right, so tonight you have another exotic deep sky object to talk about.
The bad news, Scott, for you is that we haven't run out of these yet. Okay, but we
haven't even scratched the tip of the iceberg yet.
I think we're 20 into the list of 450. So we have a ways to go. We're still up in northern. We're in northern Cassiopeia, working our way south. Yeah.
But I wanted to mention something. I'll toot your horn a little bit. I came across the article about your minerals article in Astronomy magazine, and I posted that on my Facebook feed for other people to find, and I'll post it here in chat as well. But I thought it was a nice story to read about, especially after we went through your extensive collection of minerals. So I was really happy to see the article.
Well, thank you. That's how the universe likes to make planets, rocky planets, at least. Yeah.
Awesome. Okay. Well, I'll let you get at it. Thank you.
Good stuff. Well, I'm going to share my screen, and I will see if I can share the right screen, and we'll see if we can start a slideshow, and we will talk about yet another, not Centaurus A, which is a really cool galaxy, which I regret not being able to see in Milwaukee, but it's a favorite galaxy to see sometimes when you're far enough south. And maybe what the Milkometa will end up looking something like. We will be maybe deep down in this scene, about 6 to 7 billion years from now, perhaps, when we do this dance with the Andromeda Galaxy. But for now, we will go and we'll talk about a really great, very, very rich and quite large open star cluster that's composed of relatively faint stars and a huge cloud of them, NGC 7789, that's in northern Cassiopeia. This is an object that was discovered by Carolyn Herschel in 1783. And so it's sometimes, because it's so rich and is such a clump of faint stars, it's sometimes been called Carolyn's haystack, of all things, or also Carolyn's Rose or the White Rose cluster. And it's a really beautiful object, especially you can have a fairly wide field, fairly low power telescope because it's a bright object in a very rich area of the Milky Way and see this cluster really nicely. So it's pretty satisfying even for small telescope users. It's a relatively old open cluster. It's 1.7 billion years old, and it's about 7,600 light years away in that arm of the Milky Way passing through Cassiopeia and Perseus there. It's V magnitude, it's bright, it's brighter than 7th magnitude, and it spreads over a large area, as I mentioned, 16 arc minutes. It's half the diameter of the full moon, its total extent. So it's a big object compared to the majority of open clusters in our sky that are a fair amount smaller than that. So this is a good one for telescopes of any size, as long as you're in a reasonably okay sky, as far as darkness. This object has about 6,600 solar masses, and the membership is about 1,000 stars. It's a very rich cluster, and most of the stars are reasonably faint. So here we can go to our favorite Ron Stoyan star atlas here, the Interstellarum, which gives us a good amount of detail in a pretty compact package. And you can see the area around NGC 7789. There is another little open cluster, Stock 19 nearby, and the planetary nebula Abell 82, and a few other things, some bright variable and double stars. But it's a very rich area of the Milky Way, and you can see this even in fairly simple images of the cluster. Here's a really good shot of the cluster, and you can see the kind of colorful star field that it's in. And I think even though this is a relative close-up, you can see how rich this cluster is. It's just a very satisfying group of stars to look at because there are so many members in the cluster. Then very briefly, our old pal Alan Dyer shot this as well. It's a little bit wider field. And this I came across Alan's shot here that's a little older, and it just shows look at the incredible density of stars in this area of the Cassiopeia Milky Way. It's just really incredibly rich in terms of faint stars. So it's a good area, even when you're going away from objects like this, just to scan with your telescope. If you have a degree field or maybe even a rich field telescope, it's a really fun area to be in because the whole constellation looks very nice and colorful and stunning. So that's the next object. It's a pretty straightforward open cluster, not a whole lot to say about it. And I'll say we're in the last vestiges now, after many issues after the initial Voyager coverage of our 50th anniversary year here. I'm happy to have our newest columnist has joined us again, Molly Wakeling, on the show tonight. She's taken over the beginners column and had a tremendous start with it as well, taking it over from Glenn Chappell. We're very happy to have Molly on board, and we have lots of surprises still coming up for the end of the year with the magazine. And I'll mention very quickly, Michael and I have written this book to inspire kids about the era of space exploration we're in. And boy, again, now we have the Starmus Festival. This is going to be the 7th Starmus Festival coming around the corner for next spring. It's about 5 weeks or so after the solar eclipse next spring here in the United States. But in Bratislava, which is a hop, skip, and a jump away from Vienna, we'll have the Starmus Festival again next spring with lots and lots of Nobel Prize winners and astronauts and scientists in allied fields in chemistry and biology and other fields, and some special surprises and a whole bunch of rock and roll as well with Brian May and Rick Wakeman and many other rock stars there as well. So we hope you'll join us at Starmus. And that's, Scott, all I have for tonight. So I will
that's a lot. That's a lot. So fantastic. Yeah, and I would say that, and thanks for pointing out about the 50th anniversary of Astronomy Magazine. If you don't already have a subscription to the magazine, you need to go and get one. It is the world's largest publication of its kind, and always full of great information. You can get a digital version, or if you like to have something instantly on when you turn on the room lights, get the printed version. So doesn't need batteries. Is always there. So.
I'll tell you, Scott, the people who get the print, who are,
Yeah.
The people who've been reading it like us for a long time, they want the print. They don't want
want the
anything
print.
to happen
Absolutely.
with the print.
That's right.
So yeah,
Yeah, they get angry if you don't
they
have
they
print,
do.
right?
Yes.
Well, anyways, I'm glad you still make it in print, and it is a beautiful magazine. So thank you so much, David.
Thank you, Scott.
Thanks. Yep. Okay. The Global Star Party and Explore Scientific, we're big supporters of the Astronomical League. The experience of being near the organizers of the Astronomical League now for many years for me has left a big impact. I think that really became one of the converted when I went to an Alcon event in the 1980s, now late 1980s, and I saw how their awards that they were giving out were affecting the recipients and affecting the audience. And so, I don't think there's any other organization that recognizes amateur astronomers in the way that they do. They also support amateur astronomers who are learning and trying to become better observers through their observing programs. They have like over 80 observing programs that you can partake in, and I don't know how many award programs that they have. I should probably count them up sometime. We support a few of them, and I feel it's our responsibility to give as much support as we can. If you don't belong to the Astronomical League through one of its member clubs, then you can join as a member at large, and you just have to go to astroleague.org. But they're on every Global Star Party, and it's great to have them on. And this time, returning is Don Nab. Don, you have the stage.
Okay, let me go ahead and share my screen, see if this will
Okay.
work.
Thank you for coming on.
Oh, happy to be here. All right, let me start the slideshow. Is that coming through okay?
Yes.
Okay. Well, first thing I will mention is that Scott always helps us out in a broadcast of Astronomical League Live. And we have different programs. The next one is coming up in a couple days here, this Friday. And that's going to be with Robert Reeves, going to talk about observing and understanding the moon. And on the show will be Carol Org, who is the current president, Terry Mann, the secretary, Scott, who we've heard about before, and David Levy, who we've heard about before. So it's coming up this Friday, and at 7 Eastern Daylight Time. And you can always hook onto that from the AL League Facebook page. Okay.
Right.
So tonight I'm going to spend just a little time talking about where are the stars in our sky that are like our sun. We spend a lot of time with our sun every day, putting on sunscreen, hiding from it, and observing the stars at night. But where are other stars that are like our sun? So here's our galaxy. Here's a picture of our galaxy, an impression. We would be somewhere out on the outer arm here. And so let's look at the types of stars. 90% of the stars in the galaxy are healthy and stable. And that's sort of like our sun. Our sun's considered a white-yellow star. And it's considered in the main sequence, as scientists call it. It's still fusing hydrogen at the core. That's 90% of the stars in the galaxy. 1% are giants. Okay, these are the stars that are in retirement. Okay. It is they're no longer fusing primarily hydrogen. They're still fusing some hydrogen, but they're fusing heavier elements, and they are fuller and they are swollen, and they are the giants of the universe. much larger in size than the stable main sequence stars. Then we have the white dwarfs. These are stars that are beyond retirement and are actually at the end of their lives. They are very small and very dim. But our sun is a healthy, stable star, fortunate for us. And so we're going to move the white dwarfs and the giants to the side for a moment here. We're going to take a look at the healthy, stable stars. All right, so 7% of the healthy, stable stars are like our sun, a yellow-white star in the main sequence. I'll put that down on the side here. The next are the hot blue stars. Okay, these stars are much brighter than the stars that are like our sun. They're very bright and very large. So we'll put them down there. What's left? So we put it left, and what's left are the cool red stars. So almost 80% of the healthy, stable stars in the sky are in the cool red. They're still the main sequence, but they're dim. They're very dim, and they are essentially invisible to us, looking up in the sky. So what do we see with just our eyes? I need to move my little thing here a bit. I need to hide my floating control. There we go. So what do we see mostly with just our eyes? We see the giants. That's what we see. And we see the hot bluish stars. So if you add that up, 4%, 1%, we're only seeing about 5% of the stars in the galaxy is all we can see from the Earth. So let's take a look at maybe what are the stars we're looking at in the sky. This presentation actually more fun when we have some chance to interact. I usually ask people, say, what is that constellation? Can anyone name it? And if you have any experienced astronomers, they'll say, oh yeah, it's Orion. So here's Orion, the winter constellation coming up. I did see it. I did see Orion on Sunday morning. I was at a star party called the York County Star Party. It's south of Harrisburg, and it's a small scale regional star party. But I happened to wake up early, walked out of the camper about 5 a.m. and I did see Orion. But normally we consider it a winter constellation, not a summer or fall constellation. So star, is one shoulder is a giant, the other shoulder is a giant, and the belt star is a giant, and the lower right star is a giant. We'll name these in a moment. Probably a few of you out there know what these stars are called. The middle belt star, and then we have a giant down the lower left, and a hot bluish, plus a giant double star. Okay, so you don't see any type G like our star. Don't see any yellow white stars. So Betelgeuse up in the left, Rigel down lower right. Betelgeuse being a giant. I don't remember the details, but I think Betelgeuse, if it was where our sun is, would certainly engulf the Earth and maybe as far as Jupiter, if I remember. Probably some of you out there know that better than I do. But so there are no Earth-like, sun-like stars in Orion. So you might recognize this triangle in the sky. If you go out tonight and look straight up, it will be right overhead. Summer triangle. So a giant here, Deneb on Cygnus the Swan, the Northern Cross. A giant on the one wing, giant on the other wing, giant at the very center of Cygnus, another giant. And then one of the most beautiful double stars, probably the most beautiful double stars in the sky, is Alberio. And it's a yellow giant and a hot bluish star. And it's great at star parties. We do a lot of outreach. We take a look at Alberio with a nice refractor, get a nice sharp image, and general public come up and they can see the blue and the yellow colors. It's always a lot of fun at a star party. Up here, Vega, one of the brightest stars in the sky, is hot bluish. Another hot bluish in Lyra, the constellation Lyra that Vega is in. These are both giants, and this is hot bluish. Now, the astronomers out there, which someone could tell me if they know what this is, a very famous star. This is the double double. That is, this star is a double star, but when you look at it under high magnification, each of the doubles is a double star. And they're interesting because they are oriented at 90 degrees to each other. So this is a good test of a refractor. If you can split the double-double, you got a really good sky and a really good telescope. So down here, Altair in Aquila is also hot bluish. Again, there's to Vega. I think I named these already, Deneb and Altair. Anyone see any yellow white stars? I don't. So again, no stars like our sun. So here's one that's easy to recognize. Our Big Dipper, asterism, not a constellation, asterism. And of course, the pointer stars point to the North Star. So Big Dipper and Polaris. Hot bluish at the end of the handle. Mines are an Alcor. This is a good vision test. If you can split these with your naked eyes, your eyes are still pretty good. Another hot bluish, more hot bluish, another hot bluish, another one, and the giant. Polaris is also a giant star. So again, we're looking at a lot of stars so far and some very famous constellations that we see all the time, and there are no stars like our sun. Cassiopeia. This is the first constellation I remember seeing when I was a Boy Scout. Okay, looking straight up. Had to be a winter scout meeting because it was straight up. So here I have a giant, another giant, a giant, a giant, up bluish, and I'm going to break the sequence here. Finally, a sun-like star, finally. So this star is Eta Cassiopeia. And I did see this naked eye on Friday night and Saturday night at the star party I was at. It's a yellow-white main sequence star, main sequence type G, and it's 19 light years away, and that's still considered very close in our galaxy. That's a next door neighbor. It's been more than 4 times as far as Alpha Centauri, which is the closest star to Earth after the Sun. So it's still a neighbor, very close. There's only really one more star in our sky that we can see that is a main sequence G star, and that's Tau Ceti. All right. So the stars that we can see that are like our sun, they're not very bright. They have to be close, and that's what Tau Ceti and Eta Cassiopeia are. So Spilker did a large search from 2009 to 13. It searched the sky within this area of the summer triangle that we saw, and it looked for 150,000 stars. It checked for exoplanets and sun-like stars. So if you look at actually another representation, this is the way Kepler was searching out into the Orion spur of the galaxy. Here's maybe a little more accurate scientific depiction of the actual field of view of Kepler, and it discovered 2,700 exoplanets that were confirmed. Discovered more potential ones, but 2,700 were actually confirmed. So, so our type of star is very hard to see in the night sky naked eye. Really, only 2, and the 2 I mentioned are about 4th magnitude, so we can see them most places. And there's a lot more out there. Many more, but we just can't see them because they're not close enough. That's all I had, and let me end my share here. If I can get back to Zoom.
I can help you.
Yeah. Somehow I've lost my control panel here.
Problem.
Oh,
No problem. That's easy to do. Yeah.
okay.
Yeah.
But thank you,
There's
Scott.
a couple of comments here. Don, this is off-road, watching on YouTube from the UK. He made a comment that the summer triangle, he says that Patrick Moore used to insist continuously that he invented the concept of the summer triangle. So,
Know that.
and then he also mentioned that Alberio has a yellow component, doesn't it? Or a question.
Yellow and blue.
Yellow and blue, yeah. And
Yep, one yellow,
so does
one blue,
95 Hercules. Yeah.
Yeah, I think we at star parties we call it gold. It's like you look for the gold star and the blue star.
Yeah, the sapphire and gold
Yeah,
colors.
yeah. The jewels and
Right.
stuff. Yeah.
Right. Well, Don, thank you so much.
You're welcome.
Do you, before I let you go, did you have a favorite memory of the Voyager missions?
I was thinking, I clearly remember when the encounter was happening with, I guess it Jupiter first. I remember my wife and I went over to the local university here. The astronomy department had arranged somehow to get a feed and to show it live on the monitors in the lecture hall. I remember doing that
No, that's cool.
quite a long time ago, but I remember going over there and sitting with a crowd of people to watch the image come in.
Yeah, yeah, right. And when we just knowing that it was going to go from one planet to the next, it was just, I was still quite young, but uh, yeah, everybody was waiting with bated
Yeah.
breath for sure.
Yeah. I had already graduated, but we went back to college too. I got invited to see that. It was amazing.
Wonderful. Don, thank you so much. And thanks to the Astronomical League.
Thank you.
Okay. All right. So up next is we're going to go down to Argentina to Maxi Falaris. And Maxi always blows our minds with his amazing astrophotography. And I really like Maxi's stories of how he approaches imaging, overcomes obstacles in trying to capture fine images through his equipment, and he always stuns us by what he's able to pull off. So, and also a very friendly gentleman who's always willing to extend a hand to anyone that's trying to get started in astronomy or astrophotography. Maxi, thanks for coming on to the 131st Global Star Party.
Well, thank you, Scott, for that presentation. I'm honestly and glad for what you think of me. And well, I didn't. Of course, I didn't exist when the Voyager comes out from to space. But anyway, when I was a little boy, I remember watching VHS documentaries. Narratives through the voice of Isaac Asimov, and he talks about the journey of the Voyager and the pictures that Linda took here, show us here in the presentation, and that's brings back that time in the early 90s for me. So I'm I remember that Sunday afternoon watching those VHS with my brother and with my father. And well, today is my birthday of my brother, so happy birthday, Christian.
Okay.
So well, anyway, I when she was talking about all this, all what she was through and doing, and all the team that does that amazing journey of this spaceship. It's unbelievable that today it's outside of our solar system. So, but anyway, we can still communicate with this spaceship. So for me, it's mind blowing. At that time, everyone maybe they will say it's impossible, but that's the premise of the humanity. It's break that wall and say we can do it. So anyway, well, thank you for inviting me. It's an honor to be with you tonight. What I'm going to talk to you about is what I'll be doing this last week. There's a lot of things that I've been doing. Let me share my screen. Well, first of all, you can see there's a lot of video files and another files here, because I was taking pictures of Saturn. We still having a very high here in the south hemisphere. So last weekend, last Wednesday, we had a very good, well, not very good, a good scene alert. So I tell Nico and other guys to, guys, we need to take pictures to Saturn this night because this is the night. So I was taking a lot of videos and taking 10 minutes videos in this case. And the results of this night, well, I'm still processing and practicing the rotating and everything. But for example, this is the final result that I get that night. And in this case, this is not the Voyager. This is my home, my backyard telescope, and I could capture Enceladus and Tethys moon, Tethys moon, and of course we have the shadow now on this side of the rings because a month ago it was from this side, and anyway we can see the storms from the lines well, of the planet. I also did the opposite way, turn it 180 degrees, and for depends of the perspective that you see it changed a lot, I can't understand now. I couldn't imagine now that in 2 years the rings is going to be very aligned to us. So there is going to be a very, very thin. So anyway, I'm glad to do this kind of astrophotos because I always want to capture, like the Voyager did at that time, the planets, I also tried with Jupiter that night. It was, honestly, you can see, I had to take wavelets in this picture, but it doesn't worth it because it's very low from the horizon, and
That makes
it's
it tough.
yeah, exactly. But I did my first time that I captured Neptune, so of course that's really far away. But anyway, I'm glad to take a chance to give this planet for the first time. So, well, this is what I've been doing with planetary. And when the weekend came, we tried to organize to be in Alberti. So I asked to Marcos if I could be there. And when I see the Google Maps satellite images, this was almost 3 weeks ago. And you can see here, there's a really huge circle because they are constructing constructing the observatory right now. So I'm really glad to what is happening here. And Scott, I sent you a picture that day, but I think that you couldn't see it. But anyway, I'm really glad that this project continues, besides of other things in Argentina for now. Anyway, we went with Germán Baccaro, so we can do some astrogazing and taking pictures. Let me share you these pictures that I took that afternoon. There's a lot of telescope here and equipment, and you can see the new building in this sunset. Here's my principal equipment, then my little one with the Ascar ACL 200. Then I bring for the first time the Dobsonian telescope, and Germán bring this is I don't know, is not a Smika Sagan, I think, but anyway, this is a really huge telescope and very powerful. And he went with, do you recognize this mount, Scott?
Oh, yeah. Yeah,
So
IXOS 100. It's nice to see
exactly.
it working down in the southern hemisphere. That's cool.
Yeah, exactly. So he bought it a couple months ago. So he went with his new gear to give a chance. And this is from another angle. For example, here's Herman preparing everything, and here's the IXOS 100. And you know, we had a really windy afternoon. The wind stopped, so
Nice.
I was great. Yeah, but anyway, at the high altitude, it was really windy, but we prepared the equipment, so we don't going to be at home very early. So we start to prepare everything. He's Herman when I take the pictures. And well, I did this little time lapse a couple minutes ago. So let me show you if you can see it, the full frame.
Yeah.
Mhm.
Okay, I'm going to start it. This is almost 1.5 hours, I think. You can see is Scorpius here, going to the west, the Milky Way. Oh, here's again the line that goes there. There was an airplane, and you can see here the Milky Way is parallel with the horizon.
Look at that.
So when you
This
have
is why
it,
you got to go to the southern hemisphere to see this. You know, this is cool.
exactly, and see how the equipment moves, because we was started gazing, taking pictures, and watching through the Dobsonian and see what we could get, because more later the scene it wasn't perfect, but anyway, I say okay, I have to take pictures because at maybe 2 a.m. the weather says there are going to be clouds, so no, we have to do this. And well, you know, I really love to do this time lapse, and when I was doing it, I saw from through these trees here on the right, it was the first time that I saw a meteor, a bluish meteor, you know. I saw green, I saw red, I saw yellow, some white, but blue, you know, was incredible. I remember the little crystals from the lightsaber on Star Wars, you know, something like that.
Right.
But you know, it was amazing. So when I was capturing, I was working with an icon and the ZWO, and the objects that I take place first at the night was the conjunction of the moon and Mars.
That's nice.
So this is with the Nikon and the Ascar.
Mm-hmm.
I had to take a chance, but also with the
Yeah.
F4.
Tough in.
Yes, here's
That's
Mars
cool.
and here's the moon, you know.
Wow.
We couldn't get yet the Nishimura comet because it's really low, and you know, I give it a try yesterday, but I think maybe tomorrow, if not cloudy, I will give it a chance again. But it's almost impossible from the brightness of the afternoon, you know. But anyway, this is what when I started the night. So with the principal equipment, I started to point this place that is in the Corona Australis. You know, this is a really good place. A lot of cloudy and nebula. You know, this is not cloud from the night, it's nebula, nebulosity, gas, dust, and everything. And you can see how the stars shape give the shape of this when they're bright stars gives color to these clouds. And you know, I didn't could get much more detail. Like I say, it was a really good. It wasn't really good night for get details, but anyway, I really love to capture this again and give it a try. So I was doing almost 2 hours taking pictures, and all the stars, even the guidance says they are wrong. The single picture was star rounded, so that means that the night wasn't really good anyway. But then I start to see what the next object that I could get before the clouds came, and I want to try it with a galaxy and give a chance for the first time to the Fornax A and B. And this is a really good. It's not too common to capture this one, because when you try to, sometimes you can take pictures of the core of the galaxies, not the dust. So it's a really huge object that you can capture, but not too many astrophotographers from here capture it. So you can see in the core of Fornax A, there's a lot of nebulosity rounded. So when I saw this, when I get the stack, so I say, okay, honestly, worth it to give it a try. So maybe next time, if the weather says it's going to be much more better, I will try it again. So to get more details.
Lots of galaxies.
There's a lot here, because it's in Fornax constellation besides Eridanus, and in Eridanus there's a lot of galaxy clusters that doesn't fit on this field of view. I had to make a composition to bring them a mosaic. Exactly. So anyway, I did this with the principal equipment, but then with the little one and the Nikon, I captured 4 objects that I didn't process yet, but I want to show you, for example, what I get. This is known by the Rho Fucus constellation, and there's lots of objects here, because we have Antares, M4. Well, I don't remember another names of this place. There's a lot of nebulosity, but I'm still working with these violet places, calling Amglow, because the Nikon's really old, but it's give me a battle to try to remove this the stacked images. I tried with darks, vias, and everything and flats, but I don't know what is going on here, because when I go there to M8 and I stacked it, there's no Amglow here, because the dark calibration says take them off. So anyway, I did this I think a half hour. So anyway, there's a lot of info here to work it. And more later, because at that time this was going to the west. So more later, I give it a try to the Large Magellanic Cloud, Gran Nube de Magallanes, and it doesn't fit all of it on this field of view with the Nikon, but here's the Tarantula Nebula. Here's the core of the galaxy. And there's a lot of nebulosities and globular clusters. They are floating through this galaxy. So anyway, this is a really good object to capture. And of course, more later, I give a try to the small Magellanic Cloud with 47 Tucanae. So you can compare here with this field of view. Here's the principal globular cluster, but more down here, there's another one. Here's another one, I think. And there's a lot of globular cluster here. And of course, nebulas and inside these galaxies. But anyway.
Rich region, very much.
So
well,
what?
Actually, that's amazing. I think we are running out of time.
Yes.
But it
Sorry
was
for that.
a fantastic.
There was a lot of objects that I captured.
Yes,
so
yes, and we'll have you on next week to talk more about your work there. It's very impressive. So
thank you.
It's
a pleasure to be here.
Yeah, it's great to have you here. Well, we are going to go straight to Molly Wakeling. Molly has been on Global Star Party several times, in fact, more than several times, and she is a regular contributor also to many other online programs and social media and stuff. I think Molly is very committed to sharing the knowledge that she has, and I know that we're fortunate to have her on our program. So Molly, thanks for coming on to Global Star Party. What was your favorite Voyager memory? Do you have one?
Well, I also wasn't around when Voyager launched, but
it's still going out there.
Yeah, I did grow up seeing those pictures mainly in the textbooks before the newer ones got added, and seeing those on. I was one of those weird kids that one of my favorite shows was Nova on PBS.
Oh, sure. Right.
So
I was part of the Nova film crew. I'll tell you the story sometime.
Oh my gosh.
Yeah, that was fun.
Yeah, I just love like that a piece of us, something that we made on our little planet, is out now in interstellar space and will just continue to exist for the rest of time.
Right.
It's without being in an atmosphere, things don't get broken down in space the way they do on the planet. So it's just going to keep going for tens, thousands, hundreds of thousands of years, and I don't know, maybe get picked up with part of its name scratched out.
What is this?
and that record maybe not too destroyed by micrometeorites and still able to be read. But yeah, just a piece of us being out there in interstellar space for the rest of time. It gets me. It gets me every time.
Me too.
So I absolutely love that fact. And yeah, how it's just been so recently that we've gotten these close-up views of the planets in our own solar system, and just wonder how there's still so much that we don't know about the planets, and how we've only been to some of them once, which is mind-blowing. Right. So hopefully much more to come from future spacecraft for sure. Well, I'm going to go a little bit further out than the solar system tonight, but not outside the galaxy, with the Cocoon Nebula. So I like to come on and talk about something that I've imaged before, and talk about why it's what's interesting scientifically about it, or also what's interesting to look at about it, and how to look at it, how to image it, because there's so much cool stuff to look at out in space, and especially when you have access to photography equipment, you can see even more than you can see with your eye. But it's also really enjoyable to go look at these things visually as well. And yeah, so I like coming on here and talking about these things. And I haven't been able to do as much outreach stuff lately because I'm in a critical end phase of my PhD. But hopefully when that's all done and I get moved on, then I can continue to get back into more of the outreach events I was doing a couple of years ago. So yeah, all right. So the Cocoon Nebula is sort of like the Trifid Nebula, where it's actually 3 nebula wrapped up in one. You have an emission nebula, a reflection nebula, and a dark nebula. So the emission nebula component is the pink that you see here, the red mixed in with the white starlight. That is the hydrogen alpha emission, so hydrogen gas that's being energized by the stars in the nebula. And actually, primarily by that one star in the middle is where most of that light is coming from. It's energizing the hydrogen gas, which is causing it to glow. And one of the colors, one of the optical colors it glows in is this deep red that is the primary, is the brightest emission for basically anywhere in space, but particularly for hydrogen. The nebula also includes the open cluster IC 5146. Very commonly, I think probably always, emission nebula are associated with star clusters because new stars are typically being born in these emission nebula, in this cloud of old stardust. So where can you find the Cocoon Nebula? It's I like to also mention things that to talk about targets that are currently up that you can go see now instead of having to wait 6 months. And as we're getting toward the end of summer, we still have Cygnus relatively high in the sky, and it's not too far from Cygnus and from our familiar, easy to spot stars of Deneb and Saturn. I never know how that's exactly pronounced. It's also in the vicinity of another open cluster, SEA 39, and yeah, so something you can still go out and see tonight if you wanted to. If it's clear where you are, it's not clear where I am tonight, unfortunately. So some fast facts. It's listed apparent magnitude, kind of varies depending on where you look. It also varies depending on whether you're talking about the open cluster of stars or the emission nebula or the reflection nebula component. But I've put down 7.2, one of the numbers I came across, which is probably more the open cluster magnitude than the nebula magnitude, because the nebula itself is relatively dim. It is 4,000 light years away, so it's within the galaxy, but still within not too far from the Earth, honestly, in terms of the galactic scale. It's about 15 light years across, which, you know, we talk about galaxies when we're looking at things out in space, and they're 100,000 light years across. And so 15 can sound really puny until you remember that a light year is bigger than the whole solar system. And imagine how enormous that nebula is and what it would be like to be inside of that. So 15 light years is still quite large and would envelop the couple closest stars to us. The main part of the nebula is listed as being 12 arc minutes across, which sounds small, but it actually looks a lot bigger in wide field photographs. And especially if you include the dark nebula tail coming up off of it, which I'm going to talk about in a second. And on the topic of it being a stellar nursery, it has been imaged a lot in infrared and in X-ray because there's a lot of young stellar objects in it. So these are newly forming star systems that are sometimes not quite fully formed stars yet, I think, but they're getting hot enough to emit X-rays, which is pretty hot. So that fusion process is starting. Yeah, so one of the really interesting features about the Cocoon Nebula that makes it different from the many other emission nebula that we can see is this long tail of dark nebula. I don't have a great picture of it that I've taken, but I don't know how well this is coming across, but it's sort of, first of all, a cloud around the edges of the nebula, and then also this really long tail that heads up westward from the nebula. And when you're out at a very dark sky site, you can sometimes see the dark nebula because you see the extinction of the stars behind it. And because it is in Cygnus or near Cygnus, which is a very star-dense constellation, you can sometimes see the dark nebula in that area because it blots out the stars that are behind it. So an opportunity to go see a really cool dark nebula. So a dark nebula is a cloud of light absorbing molecular dust. So as opposed to the ionized emissions of the emission nebula with hydrogen and ionized oxygen and sulfur and nitrogen and things like that. These are non-ionized molecular elements or molecules that are absorbing light instead. That's what makes it a dark nebula. So they consist of both submicron dust particles coated in frozen carbon monoxide and frozen nitrogen, but they also contain a lot of organic compounds, which I think is fascinating, like ammonia, formaldehyde, I practiced this yesterday, cyclopropanolidine.
Don't you hate that? I think they did this on these chemists do this on purpose, so.
They want to keep us knotted tongue physicists out of their world.
That's right. That's right. Mm-hmm.
And so it's fascinating to think about the fact that there's organic compounds out in space. You typically think about organic compounds being on planets or in comets inside of solar systems, but there is chemistry happening out in space, and there's chemistry happening out in space that doesn't happen naturally on the surface of planets, including the Earth. And the reason why some of this unique chemistry happens out in space is because it's cold, but mainly the spaces between different molecules is very far apart. So ordinarily, compounds that could be briefly made here are going to either fall apart or go into some other kind of chemical reaction very quickly. But out in space, it could be a while before a particular molecule runs into another molecule. And so you get a lot more of these molecules that are too reactive to exist naturally on Earth and other planets, but do exist out in space. And the way that we know that these chemicals are out there is through radio astronomy, where we can, because the molecules are going to emit and absorb light on much longer wavelengths than optical light. So you need the radio to look at some of that spectra. So yeah, dark nebula are very cool. And I don't know how they end up being connected to the formation of organic molecules on planets and comets, but it'd be fun to go learn about that sometime. See if there's any connection. I like to also show pictures of what these objects look like in different wavelengths. And one of the pieces of software I use for this is called Aladdin, which has a huge repository of images from every space telescope and every ground telescope survey, almost everyone that exists, I think. And you can look at any part in the sky and look and see what data are there and go look at a variety of different types of data. So oftentimes radio is pretty low resolution. And so there wasn't much in any of the radio images I looked at, even for the dark nebula part. So just sort of splotchy all over the sky. So not much of an image here for this one. I picked one of the frequencies at random at 70 gigahertz from Planck. But there's a really pretty picture in infrared from the Herschel Space Telescope, which was mainly looking at some of those young stellar objects that are in the main part of the nebula. And also these young stellar objects are also in the dark nebula tail, which I think is fascinating. And so this is a starless, so they removed the stars like you can do in PixInsight. They actually probably used PixInsight for this. A view in infrared of the nebula. And I think this is the main part of the cocoon with that molecular dust tail going up in here, which absorbs less infrared, it looks like, than it does for optical, maybe emits some infrared. Yeah, really cool picture from Herschel Space Telescope in infrared. There was also some, you can kind of see that there's something that resembles the Cocoon Nebula here in ultraviolet, which I thought was interesting. I don't know why they chose red for the color, but this is from the Galex survey. And then X-ray, this is roughly the same field of view. I think I'm a little more zoomed out in this picture, but there's a bunch of little dots here. And those are those young stellar objects that I mentioned earlier that sometimes glow in X-ray radiation, which means that they're very hot to be able to put out that high frequency of light. And there was something here for gamma rays, though. Nothing in the Cocoon Nebula is hot enough to emit gamma rays, or at least not a significant amount of them. So there wasn't really any imagery there. Whoops, left that up from a previous one. Observing the Cocoon Nebula, not the Bubble Nebula. So because it's in Cygnus, you can see it for a good portion of the year if you're in the Northern Hemisphere, since it is up high, almost at zenith in our sky. So I put from June to December on here. Depends on how early you like to get up in the morning in the springtime to be able to go look at things that are along the Milky Way. But if you like to observe in the evening and then go to bed, you can still catch Cygnus before it sets all the way until December. So even though it's in Cygnus, you think summertime, you can actually see this in the wintertime as well. It is difficult to observe visually because it is mostly the red emission nebula and our eyes are very insensitive to red. But if you're out somewhere very dark, and from what I've read, a 6-inch or larger aperture is recommended from a very dark sky site. Maybe if you use a nebula booster, you may be able to make out more of the hydrogen that's there. I don't know how much hydrogen beta is there, which is the bluer wavelength that hydrogen emits that is more picked up with the nebula filter, but maybe you'll see something with that. Or from a dark sky site, you can try to make out some of the dark nebula by looking for the stars that are extincted behind it. Photographically, it is a much easier object to catch. You don't need a whole lot of time on it, actually. It's very strong in hydrogen alpha. Which you might think might make it a good narrowband target, but actually it's much better done in wideband because of the reflection nebula and because of the dark nebula, neither of which you're going to catch if you're imaging it in narrowband. So maybe do it in wideband, and if you want to add some hydrogen alpha to it, then you can kind of boost that hydrogen alpha signal and color. One of the cool things about it is that it's really great with a narrow field of view or a wide field of view. So if you're using a Rokinon or Samyang 135mm camera lens, or if you're using a 11-inch Cassegrain, you can image this and you'll get something nice out of it. So it's good basically at any focal length. The deeper you go, the more you'll get, and by deeper I mean more exposure time, getting more of the dark nebula and more of the reflection nebula and more detail in the emission nebula. But you don't need really a lot. The picture on this slide is just 2.5 hours at the Okie-Tex star party, which is pretty dark, which lets me pick up that dark nebula very quickly. Oh, yeah. But on the next slide, I'm going to show an image from a Bortle 5 site that I only got 4.5 hours on and still got a nice shot of it. So it really does not need a lot of exposure time, even though it is quite dim visually. So I'll leave you with my best picture of it so far, which I forgot to put the date down. I think I took this last year. Yeah, probably something like that, relatively recently, out at a Bortle 5 site at a local state park. This is with my Takahashi FSQ 106, the Optolong L Pro, so wideband, and it's just 4 hours, 20 minutes of data on my one-shot color camera, my ZWO 2600.
That is beautiful.
Thank you.
That is beautiful.
I'm quite pleased with this one. I would like to get more data at some point to get more of the dark nebula up here and around it, but using the Takahashi, my stars came out very nice, and it really, like the images shown earlier, there's so many stars in Cygnus. Yes. And it's just, you could just fall into them. It's just incredible. And yeah, that's what I got.
Fantastic. Well, you got a lot, Molly. That's awesome. That's awesome. I put a link to the Astronomoly log, which is the official log or blog of Molly Wakeling. And so
I'm a little behind on updating it and putting much else on there, but it does have a link to my Astrobin where I do keep relatively up to date with posting images, and also to my Facebook where you can see both images and sometimes I post like, here's a picture of my telescopes tonight, or I'm out camping this weekend or whatever. So yeah, it has links to those sites as well.
Thank you so much. Thanks for the fantastic presentation.
Thank you.
All right. Okay. Up next is Kelly Ricks. Kelly came on for the first time at the last Global Star Party. She is a very she's a creative force in the field of art, music, and also in astronomy. I think that she's we would consider her to be a protector of dark skies, and she has she comes with a lot of passion for observing the night sky, and she puts it down in beautiful artworks I wish that I could hear her perform music as well, but I don't know how much she does of that anymore. But she is it's kind of like a Renaissance person. And so I'm very glad to have Kelly Ricks on again tonight. Thanks for gracing the 131st Gold Star Party.
Well, thanks for having me back again. It's a real pleasure to be here. You've been asking people about their Voyager connections, and I, like Molly, was not born. I don't remember.
Everybody's starting to make me feel old, okay? But that's okay.
Well, I will say the day that I was born in July of 1979. So that was when Voyager was traveling through the Jupiter system.
Sure.
I, found that out later. And so I have a special connection to that portion of the mission, especially because the first object that I looked at through a telescope was Jupiter. So.
Excellent.
And so this past weekend, we just finished up our Dark Sky Festival at Capulin Volcano National Monument. We had a Friday that was completely rained out and fogged out, but the Saturday was beautiful. And another connection to Voyager here, not only did we get to pass out some Deep Space Network stickers,
right.
Not many people know what the Deep Space Network is, but I get to explain it to them, and I love that.
I want one.
I actually don't know where the park got them. But also being at a volcano, I got to talk about volcanoes in space. And a lot of the very interesting things that we discovered about volcanoes in places like Jupiter and Triton and even Miranda. And I think Enceladus was Cassini. But anyway, we got a lot of that initial information and some stunning images from Voyager as well. So I referenced that quite a bit. If I can share my screen here. Let's see, is this in the correct
Yes.
mode? Okay, so this is an image from just as we were getting started for the Capulin Volcano Festival. We have some people just starting to assemble. We have our telescopes getting set up, and I'm over here in the corner talking about volcanoes in space. So anyway, so my main presentation tonight is about overlooked constellations. I've done a series of artworks about constellations that tend to be overshadowed by others, especially, for those of us who have been observing for a while, we know some of these constellations, but you talk to most people and they know the Big Dipper, Ursa Major, and they know Orion, but not many others. And there's some really beautiful ones out there with some interesting stories and characters. So I thought that I would try looking into some of those. This first one here is an illustration that I did of Lepus, which is a constellation that hangs out right below Orion. And I mean, obviously this is highly interpreted. I didn't include stars that are around Lepus, and some of the brightnesses are enhanced a bit, like if you were to go in to Stellarium and turn up the relative scale of the stars. The slightly changed shape of the constellation, I like to maybe reference some of the ideas of The Stars, A New Way to See Them by H.A. Rey, where he takes the official stars of the constellations and sort of makes them look more like what they are. So in Lepus here, the hair, one of the favorite things that I have to look at is this beautiful dark red star. And I have some of the screens over here covering up my view of this particular portion of my slide. But this red star is called Hind's Crimson Star, and it's a variable star. It has a period somewhere in the range of 450 days. And when it's toward its dimmest part of the cycle is when it really, really looks very red. But that was one of the first things astronomer showed me through his telescope, was this really just ruby red star. I found it was really stunning. All right. Oh, another object we have here is M79, hanging out in the little paw of the rabbit. Next, we have hanging out behind Orion, a truly, truly difficult constellation to see, Monoceros, the unicorn. And yes, I have turned up the relative scale of the stars in the unicorn quite a lot because it is very dim, very elusive, just like the mythical character itself. But some of the interesting objects in the unicorn, first of all, the Rosette Nebula. And when I was getting started in astronomy, I had my little 8-inch Dobsonian on my back porch, was looking through the star map, trying to figure out what to see. And I saw this really big nebula in the middle of this, right next to Orion. And I thought, well, that will be easy to find. So I put my telescope where I thought the right area was, and there was nothing there. I was very confused and only learned later that, yes, it's a big object, but it's very faint and very diffuse. So every failure is a learning experience. But close to the Rosette, we also have the Christmas tree cluster over here, just below the horn, which, yes, I did bleed up a little bit into here to Gemini to make a horn. That's a little artistic license. Next, another mythical creature, Draco. This is a beautiful constellation. Weaves in between the Big Dipper and the Little Dipper, which I also included Ursa Minor in this view of the constellation. And the deep sky object that I like to feature here was the Cat's Eye Nebula, which is a very nice one. I'm a musician, yes. So of course, I've got to choose Lyra, which I suppose for most of us as observers, this is not so much of an overlooked constellation. There are lots of amazing things to see in this one. But typically when I've been at star parties where people have tried to explain the look of Lyra, they, instead of a musical instrument, they have instead referenced Fred Flintstone's tie, which there's the triangle and then
There it is.
tie hanging down there. So I wanted to take it and actually, play it, the musical instrument side of it. Of course, the beautiful objects we have in Lyra are the Ring Nebula, one of the great objects for a beginner to start with. Just right smack in the middle of those, between those two stars, about 3/4 of the way there, and you've got a great, the cosmic Cheerio, as I like to call it, very rewarding for a young observer, or a new observer, I should say. Also, we have M56, which is here hanging out behind her hair. And something that was referenced earlier in the night, Epsilon Lyrae, which I have zoomed in, a fake telescopic view here on the double-double. In reality, it is much further separated than this view. This is an image I got off of Wikimedia Commons, just to give you a sense of what that looks like. In addition to being a good test for a refractor and a good sky, I would say that that would also include a Dobsonian reflector. It's possible to get this in with a good sky and a good Dobsonian. So
is there supposed to be an image in the black box there?
Yes, did it not come through?
Doesn't look like it's coming through.
Okay. Well, in any case, I guess you can look at my drawing up there for some
drawing's good.
highly interpreted view. They're a little bit further apart in reality than they are in this view. All right. Next we have Corvus. And speaking of using stars to get to interesting deep sky objects, I think Corvus is my favorite constellation. At a lot of our dark sky events, we do a thing called a telescope sandbox, where we have a couple of little Dobsonians, 6-8 inches, that people can use, they can play with. And that's what I did over the weekend. I coached people through first finding a star, then finding Saturn, then finding, by the end of the night, there was a girl, she was maybe 10 years old. She found M81 and M82.
What?
From my giving her the directions on where to look, she was able to put her telescope on those objects. Corvus, of course, it's a spring constellation, but it has this wonderful pattern of stars here that leads straight to M104, the Sombrero Galaxy. I don't know if the terminology is the same everywhere, but this is my little star hopping map. We've got these two bright stars here, and then another star up here that's in a kind of a triangle. And then it goes to what most people I've heard call the Stargate, which is a triangle of stars surrounding another triangle of stars. References a very old TV show, which is no longer salient for kids. But I did ask a kid a few months ago what he thought this object looks like, and he said it's a fidget spinner. So now I call this little pattern of stars the fidget spinner. And of course, you jump from there to what I've often heard called JAWS. I think of it just as an arrow, points straight to the galaxy, and let's see. There we go, back through. Points straight at the galaxy. For someone who's never looked at a galaxy before, what a helpful thing to have an arrow point straight to it. All right, the next constellation, yes, is typically more of a southern hemisphere object. I can see this constellation from my latitude here in New Mexico, which is awesome. And you will notice a couple of weird things about Pyxis, the compass. First, probably you're all jumping on top of me saying, your east and west are backwards. Well, in most cases, that's true. However, if we line up an equatorial grid on top of the stars, and again, I've got screens that are covering my portion, the active portion of my view, so I can't directly point at these stars. But in the drawing, typically the compass, I think the needle is used by these stars, but I have used these other stars over here to make the needle. And by following that needle, it pretty much follows, straight up to the North Pole. But in order to do that, standing in the northern hemisphere, looking south, north is up and east is over here and west is over there. So it's just a little bit of a different perspective. Got a couple of deep sky objects that I will probably never see. They are very, very faint. I think I put them in there because I thought they were beautiful. All right, probably my favorite constellation in the whole sky for many, many reasons. Coma Berenices, just this picturesque little right angle of stars with a gorgeous star cluster, Malat 111, dangling down. This is the hair of Berenice, Queen Berenice of Egypt in the 2nd century BC. She sacrificed her hair to help ensure that her husband Ptolemy would come home safely. He did. And so they're seen in a loving embrace here in this picture. Coma Berenices has got some great objects in it. There's, of course, the Needle Galaxy and the Black Eye Galaxy. But my favorite aspect of this particular constellation is the fact that it contains within it the galactic North Pole, which is something I had never heard of until I read this wonderful book by Tyler Nordgren, Stars Above, Earth Below. And he was talking about, okay, the Earth spins and we have a pole where the axis is pointing. Well, guess what? The galaxy spins as well. And there's a pole, an axis of that rotation. And it just happens to be in Coma Berenices. When this constellation is high in the sky, when it's straight overhead, and it helps to be in a further south latitude, the Milky Way is all around us on the horizon. We are looking straight up and out of the galaxy. You won't see the Milky Way anywhere. Which, this is a very this is a very helpful constellation to be able to reference for people who come to a star party and say, the one thing I want to see is the Milky Way. They say, well, you're not going to see the Milky Way tonight, but here's why. Because we're looking straight up and out of the galaxy. All the way around us on the horizon is the galaxy standing upright, and we're looking out into clusters, hundreds, thousands of galaxies. In this image, not only do I have the needle and the black eye, but also a reference to Markarian's chain. Of course, that's in Virgo, but right next door, just, clusters of galaxies. It's, so many galaxies, you can't find your way around these galaxies. So, well, that wraps up what I have to show. My website, deepskykelly.com, where I have a lot of my other artwork. And let's see, stop screen share. There we go. All right. So thank you very much.
Muted, Scott. Scott, you're muted.
I think you're muted.
Blah, 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 blah.
There we go.
There you go.
That always happens to me. Anyways, I muted it for a moment because we were getting some thunder back here, and I did put a message out that if in case I lose my power, the magic of Zoom will keep the program open. So if that happens, I'll blank out and I'll come right back in. But what I was saying is, Kelly, I can tell that you really know the sky extremely well. To be able to explain how to find a couple of galaxies in the sky that I know a lot of adults struggle with in trying to find on their first go-arounds. That's testimony to how well you are interpreting the sky. So that's great. That's great.
Few little tricks, learning the constellations, and you start to see the patterns in the sky. Stars lead to other stars, and it's so yeah. I guess it's practice.
Right. Okay. All right. So we are running a little ahead at this point, and so we are going to take a break and come back with Marcello Souza and a special first-time person, and I hope I don't ruin the pronunciation of the name, but it's Oded Ben Heron. And Oded comes from Norway, and he is someone that loves to mix different disciplines in order to better understand science. And he is also someone that is involved with the Global Science Opera, a fellow musician, Kelly. So, all right. So we are going to take that break, and we'll be right back.
We knew we were on a journey of discovery when we launched the Voyager spacecraft, but we had no idea how much there was to discover.
We had a sense that we knew what it felt like to be Magellan or Columbus.
Time after time, we're surprised by seeing things that we had not expected or even imagined. Volcanoes erupting from a moon isle, the possibility of a liquid water ocean under the icy crust of Europa, Titan, where we found an atmosphere, Uranus, small moon Miranda, which had one of the most complex geologic surfaces we'd seen. Even at Neptune, Triton, 40 degrees above absolute zero, even there were geysers erupting.
It's the only spacecraft that's gone by Uranus. It's the only spacecraft that's gone by Neptune. Everything we know about those planets, we know from Voyager.
To see those first pictures coming in from the outer solar system, for the first time, what had been a point of light in the sky was a place.
I really credit the people that designed the mission, both the engineers and the mission planners and scientists, because not only did they build an extremely robust, durable spacecraft, but they had the vision to send it on a path such that it could get out into interstellar space and carry a gold record.
And here was this Noah's Ark of human culture that was being sent to the outer planets and then beyond to wander in the interstellar darkness for 1 billion years.
Hello from the children of planet Earth.
On Valentine's Day, 1990, Voyager 1 looked homeward, and what did it find? Not the frame-filling Apollo Earth, but instead that 1 pixel Earth. That's here. That's home.
The Voyager spacecraft are in the outer layer of the heliosphere, the giant bubble the sun creates around itself with its supersonic wind. Voyager today is headed for the edge of interstellar space. That's the space between stars, and it's filled with material that has been injected by the explosion of stars, matter which came from a particular direction, creating a wind which has shaped the bubble in which the solar system is surrounded. Voyager really has changed our view of the solar system. This will be a milestone in space exploration, leaving the solar system, leaving the bubble, and entering interstellar space for the first time.
Hello, everyone. Welcome back. Hope you had time to stretch and get that sandwich or nice drink so that you can enjoy the second half of our program. You are watching the 131st Global Star Party with the theme of the Voyager Effect. And so we've had some fantastic speakers so far. We have more to go here. And so we will go to Brazil, to Marcelo Souza. Marcelo, how are you? And thanks for coming on to the Global Star Party.
Hi, nice to meet you. Thank you for the invitation, Scott. Nice to meet all of you. It's a great pleasure to be here. Thank you for the invitation.
Thank you.
This week here, we have a new activity that we are developing here. Dr. Oded Ben-Horin is here with us here in Brazil. And since Friday, we have the opportunity to organize many events with the participation of Dr. Oded. Hi, Oded.
Hi, Marcelo. Hi, Scott. Hi, everyone.
Yeah, nice to meet you.
Nice to meet you all.
I will show before Dr. Oded talk about the project, I will show some images of part of the activities that were developed here until today. Let me share here the screen. Here is the first event here when Dr. Oded arrived here in Brazil. Was a meeting with the head of the Department of Education of all the state of Rio de Janeiro, with Dr. Oded, because Dr. Oded will talk about the Global Science Opera. That's a fantastic project that associates arts and science, and we participated since 2015 in this project. And now it will be developed in all the states, in all the public state schools of the state of Rio de Janeiro. That's something fantastic. They will give the opportunity for the schools to participate in this project here in Brazil. The state of Rio de Janeiro have almost 20 million people living in a lot of state public schools. Then we will have many schools involved. This was the first meeting during Friday. We have had 6 events here with the participation of this was another event with the participation of students, and many of the Global Science Opera was associated with astronomy. This is something fantastic since the first one. Here, the kids from another institution here in Brazil that Dr. Oded visited here, and he organized a workshop for the kids that were there. Here we are together here. This is a fantastic register of these events with the participation of a lot of students. We had many meetings here with the head of the Department of Municipal Department of Education of Municipal Governments. Here is the staff of a private institution that's very big here in Brazil. They have the institution in many cities and states. Here I visited to a state public school. These are students from this state public school. Here, located here in Campos dos Goitacazes. Another image from an event in another city with the staff of the Department of Education of the city and with the students that already participate in this fantastic project that is Global Science Opera. This is part of the images of the events that happen here in our region with the participation of Dr. Oded. Thank you very much to be with us, Dr. Oded. And he is the creator of this project. Thank you, Oded, to be with us here, and he will be participating now here. Oded?
Okay.
Thank you very much, Marcelo, and for that wonderful introduction. And Scott, could you please confirm that it would be my turn to speak now?
Yeah, sure.
Yes.
Yeah.
Okay, great.
We're kind of
First of all, it's really exciting. Okay.
Yeah.
Then we'll do it that way. Then I will start with an informal note. It's really exciting to be here for several reasons. Not least because as a 7-year-old living in Florida, I had the opportunity to be at Cape Canaveral in Florida and watch the launch of Voyager. So this is an extremely nice circle, so to speak. Yes, I was living in Gainesville, Florida at the time. So I'd like to say a few introductory words about the Global Science Opera, which is the education initiative that Marcelo was introducing. A little bit of background about myself first. I'm a musician and head of Department of Arts Education at Western Norway University of Applied Sciences. The Global Science Opera is, per definition, the first globally produced opera initiative in history to our understanding. Beyond that, it is also a creativity and education initiative that has been active in approximately 50 countries and which started in the framework of the UNESCO's International Year of Light, which was in 2015. Literally what we do in practice is each year we take a scientific theme and in dialogue with an international level scientific organization, create a science opera with mainly children, but also scientists and artists themselves in dozens of countries. Scientific themes that we have tackled so far include light pollution, particle physics, ecosystems, the human mind and creativity. And very excitingly, this year, we are receiving direct inspiration from the Goddard Space Flight Center of NASA to create an opera about the new science that is being discovered through the Webb telescope. Our opera is called Unfold the Universe. And as Marcelo mentioned, one of the countries that has been most active in global science opera since it started has been Brazil. And we have seen wonderful contributions from hundreds of students here in Brazil. And now I am in the city of Campos where Marcelo is living. And we have had very exciting meetings with the education minister of the state of Rio de Janeiro in order to see how and in what new ways children in many schools in the state of Rio de Janeiro can keep exploring science through art and keep exploring art through science and to see what arises in the interaction between those. And I think I'll stop there and I can answer any questions about what I've presented so far. Or if time allows, I can go more deeply into any of those issues. Thank you very much.
I have a question. I mean, how do you, I've seen music combined with science in various different ways. But I find it a recurring kind of thing that happens where it involves astronomy. I too have hired. I'm not a musician, but I've hired musicians to perform live music while people are stargazing and experiencing the planets or the Milky Way or something like that. And I think it really reinforces the experience. I think it creates experiences that people don't forget. What is your take on that?
Absolutely. And we have research that supports that claim. And what we're trying to do with that fact or that understanding is bring it into schools and see how this combination between science and the arts can strengthen both science and the arts. Remembering, retaining information is one aspect of the learning process, but of course there are many more. We can ask what kind of creativity arises in the interaction between science and the arts. In what new ways can children understand science and the art beyond quote unquote, just retaining the information in the arts and in the science. So absolutely. Another aspect in response to that question, Scott, is what happens if we take that kind of activity to the extreme? And if we start with what you're saying, okay, we are doing something fascinating by hiring a musician to create musical or other artistic dissemination of the science and thereby creating a new piece of music? Can we take it to the extreme and ask ourselves, if we do involve arts in scientific exploration, could the arts lead to new kinds of explorations in science? And obviously, if we're looking at the work of Leonardo da Vinci or things that Albert Einstein has been saying about the connections between arts and science, then yes, and there are scientific instruments that are artistic works as well. So I think this interaction between science and the art works in many ways, and it's very well worth exploring even further. So thank you for giving me this opportunity to share some thoughts and some experiences about what we've been doing in Global Science Opera.
Oh, fantastic. Fantastic. Well, thank you very much, Oded.
My pleasure.
You are in Brazil now with Marcello. How much longer do you expect to stay?
I will be staying in Brazil, unfortunately, just till tomorrow. I'm heading to Phoenix, Arizona. I'm going to do a Global Science Opera workshop in a high school in Phoenix, and then I'm going to head back to Norway, where I am permanently based. Yeah.
Wow. Fantastic. Okay.
Thank you.
All right. Thank you. Did you want to add anything, Marcello, before we go on to our next speaker?
I would like to emphasize that it is a fantastic project that is changing life of the students here in our country, because many of the students said that after participating in this project, they feel motivated to study science, to have they have the opportunity to we participate since 2015 in many different topics of science, and we have students here that they develop the music, they write the lyrics of the music. Then it's a fantastic experience, and for us we are very happy with the opportunity to be involved in this project. Thank you, Oded, for the opportunity. It's fantastic. And thank you very much, Scott, for the invitation. It's a great pleasure to be here.
Yeah. Well, thank you for
so
bringing
much.
on your special guest. That's wonderful. Thanks for sharing. Okay. All right. So we are going to transition here to Robert Reeves. Robert is an extremely gifted photographer, astronomer, communicator in his own right. He's got some books on astrophotography, but he shares with us his love for the moon through his lunar postcards, or his postcards from the moon program that he runs here on Global Star Party. I know that's not what he's all about, but good Lord, this guy knows more about the moon than I think all of my friends that I would have considered to be lunar experts combined. So, Robert, thank you for coming on to the 131st Global Star Party.
Yeah, my pleasure being here. Can you hear me okay?
Hear you just fine.
Okay, good, because I'm on a different laptop tonight. My normal laptop is in the observatory controlling my telescope as we speak.
Okay.
So I'm kind of keeping an eye on it here by a wireless or a Wi-Fi connection. It's cruising along on the wild duck cluster as we speak. So hopefully everything will work well with this different laptop. I do enjoy the moon, but as you mentioned, I have experience in other areas of astronomy as well. I've written 3 books about astrophotography, but I have always liked to return to my my roots in astronomy. The moon is what got me into astronomy to begin with. Before there was even a space program, the moon already had my attention. So I love promoting the moon and talking about it. And I just recently released a book about the moon. It's available on Facebook, available on Amazon, And I'm going to go to screen share. I've got to throw up the obligatory initial. Okay. Is everything screen sharing okay?
We see thumbnails.
Oh, here we go again. Different laptop, same problem. Let's back up here and you are sharing. What do I have to do to make this work? We made it work last time. Yeah, double clicked on it. I'm seeing it on my screen. And it's not, all you're seeing is the
just the thumbnails.
Okay, let me stop screen share and we'll recycle. Stop the share. Okay, you should be seeing me again. Go back to screen share and bring up. Now you're seeing the screen with the thumbnails, correct?
Yes.
And now we'll click on one and still thumbnails, or are we seeing the full screen?
Still thumbnails.
Well, hell. I don't know what it is about my connection that creates this issue. We got it to work last time. Okay, let me stop share.
Yeah, we were seeing the images over your thumbnails last time.
Yeah.
I think what you have to do is you have to open one and then go find it and share it after you've opened it.
Okay, well, let me drop out of there.
Unless you have like a player that's playing one image after the other.
Okay, now what do you see?
Okay, full screen. Looks good. Exploring the Moon with Robert Reeves.
No, cool. But I've got another problem. I just realized this laptop does not have my slide player. I can't advance the slides. I've trapped myself by switching laptops. I may have to. Anyway, okay. Starting off, like I said, I just came out with this new book about the moon. It's been out on Amazon for about a month now, and getting quite a bit of good feedback about it. People seem to be enjoying it. So let's take a quick look here at the title and just do a search for Exploring the Moon with Robert Reeves on Facebook. It'll take you straight to it. Available in hardback and paperback. And away we go. Let's back out of here and try to bring up the next one. Screen sharing has stopped. What?
Well, you want it to.
Okay.
Yeah. So you open up the next one and then
we're just gonna have to cycle back and forth through this. I've got to. Yeah, well, trouble is that I don't have the slide viewer on it that will advance to the next one, so I've got to bounce back and forth, in and out, in and out. Trap myself. I didn't realize that my player isn't on this. Anyway, the title slide: Postcards from the Moon. Postcards from the Moon is my theme is exploring some of the sentimental favorites on the moon. That's what I started to do last week, but I had forgotten what the title was because it's been several weeks since I was last here. But we're going to look at a couple of areas on the moon that are sentimental favorites for all observers. They enjoy these particular areas and want to know a little bit more about them because they're just naturally drawn to the beauty of these areas when they're observing. So I will back out again, advance to the next slide. Oh boy, stop this. And where am I here? I've got a screen share. And my one of the slides that I bring up every time, though, is to remind everybody that there are only two primary landscape making process on the moon. It is either a feature on the moon is either created by volcanism or by an impact. The gross features on the moon, the giant basins, the craters, these are all impact features. The dark areas, the basalt, is the result of subsequent volcanism. And sometimes volcanism modifies existing craters, definitely have modified the Great Basins and filled them with the basalt and turned the basins into the caricature that we see as the face of the man in the moon. And back out of this one, go on to the next one. This is going to be a process. Bringing up the first one and back to you and back to screen share, and boom, here we are. The Serpentine Ridge. There it goes. Okay, the Serpentine Ridge is our first feature today. It's on eastern Mare Serenitatis, the man in the moon's, basically the man in the moon's right eye, the Sea of Serenity. And it's a wrinkle ridge, which is a feature that is created when sheets of basalt slump toward the middle of a basin. The weight of the basalt flooding the basin has mass. It depresses the center of the basin, so all the basalt tries to slide toward the middle. That creates ridges where basalt buckles up and crushes into itself. Another form that creates these wrinkle ridges is a buried basin impact ring. Now, what the single image doesn't reveal is that the Serpentine Ridge, this twisty, ropey looking feature, is actually part of a series of ridges that completely encircle the inner part of Mare Serenitatis, just offshore. So this could very well be the manifestation of a buried basin impact ring in Mare Serenitatis. In this case, the Serpentine Ridge is actually the twisted, joining twisted form of two different wrinkle ridges. The upper one, they're called Dorsa Lister and Dorsa Smirnov. These wrinkle ridges on the moon have the scientific name of Dorsa, and they're named after well-known Earth scientists. So in this case, Dorsa Lister, Dorsa Smirnov. And we'll navigate over to our next slide. Whoops. Okay, I've lost my screen. Let me come back. There we are. Alrighty, now go back to screen sharing. What a process. This isn't going to happen next time. I'm going to be ready with this laptop. Okay. Your screen share is loading. Come on, load. Are you seeing it yet?
Yes.
There it goes. Okay, you should be seeing another view of the Serpentine Ridge. Yeah. Here we're seeing it just as it's breaking into sunrise. The sunrise is streaming across the eastern part of Serenitatis, and we see the Serpentine Ridge just cresting into the sunrise. It's a very shallow, low feature, no more than about 300 meters high. Yeah. They can be up to 5-10 meters across, and they can be hundreds of kilometers long. So they are among the shallowest features on the moon, but at the same time among the longest features on the moon. So let's get out of here.
Navigate because of just age, or what do you think?
No, it's just the nature of how they build up through the process of the basalt buckling up against each other. Mm-hmm. And where am I here? Back to screen share, back to the next picture. And once it loads up, we will see Mare Nectaris and hopefully the entire Nectaris basin. Yeah, this is taking some time.
No, that's great.
There it goes. There we go. Now Mari Nectaris, and you will notice down on the lower left from the circular Mari Nectaris, a very distinct ridge. It's in shadow here because we're seeing at sunset. That arcing ridge is the Altai Scarp. Scarps on the moon have the scientific name of Rupes, R-U-P-E-S, and this one is Rupes Altai. It is actually the surviving portion of the outer impact ring of the Nectaris basin. The inner ring is the shoreline of Mare Nectaris. And if you look closely between the Altai Scarp and the southwestern shore of Nectaris, you can see the faint outline of a third impact ring, just very faintly, just have to mentally connect the dots almost. Here we see all three of the impact rings surrounding the Nectaris, or the Nectaris basin impact rings. Nowhere else on the moon do we easily see this, the impact rings like this, except on Mare Oriental. But it's so foreshortened on the western side of the moon that it's really difficult to pick it out. So here we have the best example of basin impact rings facing us on our side of the moon. So let's get a little bit closer look at this thing and get a closer view of it, and wait for the bells and whistles to work. And 1, 2, 3, come on, giddy up, go.
There we go. Wow.
Got it. Okay. Now, this is sections of the Altai Scarp at sunset, casting a shadow. At sunrise, the sunlight fully illuminates the face of these cliffs, and we see the Altai Scarp as a white line feature. At sunset, we see it as a black line feature. Now, this Altai Scarp is so prominent, you can see this thing in binoculars. Just looking at the waxing, this feature is so prominent that is easily seen simply with binoculars. And let's go on to the next slide, and we will see the opposite sunset view of it, or sunrise view of it. And up we go. Now, this is clunky, but it's working.
I did notice that there are, it looks like there's little arrows to advance and go back right underneath your image. I don't know if you can see those or if they work.
You're right. Let's see if they do. I'll try that next time. This thing may have a built-in viewer in Zoom that I'm not aware of. Okay, we'll try it. Anyway, here we see the sunrise on the Altai Scarp. And I've always thought that it's so cute how Piccolomini crater at the middle right just acts like a cork and just stops the flow of the Altai Scarp. That's just coincidence, of course. Piccolomini overlaid the surviving eastern tip of the scarp to begin with. It didn't necessarily physically stop it when it formed, but the overlay creates a nice artistic effect. So let's see if this will advance. Hey, it does.
There we go.
Alrighty, learn something new every day. Alrighty, another view of the Altai, and here we see it later in the day. We're getting some more shadows, and these cliffs are very, very high. They're almost 2 kilometers high, so they will cast some significant shadows whenever the sun is low. Now, moving on toward the center of the moon, almost to the very center of the disk of the moon, we're looking at near Sinus Midii, the middle sea on the moon. Actually, closer to Mare Tranquillitatis, the Apollo 11 landing site is on the left-hand side, underneath that ghostly spider-looking apparition of Lamont crater. The goal we're looking at here are the cracks and splits in the middle of the picture. the rills on the moon. And looking down toward the lower left, we also see a K-shaped cluster of rills. This area of the moon, the very center of it, just fortuitously, has quite a number of these features on it, these cracks in the moon, and each of these is formed by a different type of volcanic activity. Let's advance and get a better look at some of these. Here we see in the center the Hyginus rill, the gull-wing-shaped rills extending on either side of Hyginus crater. Now, Hyginus crater, about 8 kilometers in diameter, is the largest non-impact crater on the moon. It's actually a volcanic collapse pit. And you look very closely at the branches of Rima Hyginus, and you can see smaller collapse pits within the rill. Most of them are in shadow in this particular picture, but there's over a dozen of them. And these are all volcanic features. The rill follows this chain of volcanic collapse pits. Down toward the left-hand side, we see the Triesnecker rills, so named because they're right next to Triesnecker crater, which is just splitting the edge of the image. These rills are unlike any others on the moon. They're not linear, they're not curved, they're not sinuous. They have a structure all their own, and they are uniquely called irregular branching rills. They're the only example of this on the moon, whereas the Hyginus rill is definitely a volcanic feature. We'll move on to the next one and look at the Hyginus rill. Excuse me, the Ariadeus rill. This one is a feature called a graben, a area between two parallel faults where the land has slumped down. What happened late in or long time ago in the moon's history, a volcanic dike, which is a sheet of magma that pushed upward from the moon's molten core, but didn't quite reach the surface. But what it did was split the surface. So the land in between collapsed and created this rill. It almost looks like a interstate highway excavation. Like Caterpillar tractors have been up there very busily carving out this region on the moon. It's about as long as it is from here in San Antonio over to Houston. So it's a considerable feature. And a better look at the Triesnecker rills and Ariadeus, the Hyginus rill above it. And up at the top of the picture, notice the very dark pyroclastic area, the mountainous region. We'll take a look at that here in a minute where we can see it better in all of its form. This region is dark because it was dusted with volcanic ash that blew out all these vents, volcanic vents along the Hyginus rill. And here we have a wider field showing them all. We've got the Triesnecker on the left, Hyginus in the middle, Ariadeus scooting off toward Mare Tranquillitatis. Got Julius Caesar crater off at the right-hand side, Agrippa crater down at the middle bottom. And moving along. Hello. There we go. Now a little bit higher view. We see them all, but now we see that pyroclastic region just above the gull wing shape of the Hyginus rill. I mentioned that it's dark because it's been dusted with volcanic ash. The shape of this area vaguely resembles a heart. So I have personally named this area the heart of the moon. And like names of deep sky objects, they become semi-official in the lexicon if a lot of people accept it and start repeating it. Like, the Swan Nebula is the Swan Nebula because everybody agrees. Well, I like to throw a few names around on the moon as well. So hopefully the heart of the moon will stick. And moving on to our final area, just west of the Alps Mountains, which are the rough region on the left-hand side that are bisected by the Alpine Valley. And then just below them, we see the kind of snake-eyed crater Cassini. Got the two secondary craters inside its lava-flooded interior. But what we're really looking at is Aristoteles and Eudoxus craters. Aristoteles, the upper right-hand crater, slightly smaller Eudoxus at the bottom. In my semi-dyslectic youth, I used to call that Exodus crater and didn't really realize that it was incorrect until maybe about 10 years ago. I've called it by the wrong name my entire life. It's actually Eudoxus, not Exodus. And Eudoxus lays in a rough mountainous region north of Mare Serenitatis, but Aristoteles actually lays within the band of Mare Frigoris, the long linear lunar sea that kind of flows across the man in the moon's forehead and kind of forms his eyebrows. And just off to the east of Aristoteles, kind of midway between Aristoteles and the Alpine Valley, we see that very distinct circular ghost crater, EDG, well, EDG. My spelling is failing me. It's late at night. I'm sorry. Anyway, named after I believe a Norwegian naturalist. And finally, I last look here at Aristoteles and Eudoxus. You can see the interior of Aristoteles has been flattened out a little bit. It's not as rough as Eudoxus. Impact melt will sometimes flood the interior of a crater and pave over its floor. In this case, we see very little evidence of a central peak. The crater could also be, if it's old enough, it could be filled in with debris thrown in from other impacts or basin impacts. But in the case of Aristoteles, it's not old enough for that to happen. So this is probably impact melt that's flooded the interior of it. Now, Eudoxus on the bottom, you can see remnants of the central peak in the middle. You can see the collapsed terraced walls that crumble and flow downward into the interior of the crater. Those are also very visible up on Aristoteles. The eastern portion has stair step terraced walls where they go down in a series of benches. But look at the northwestern side. That particular side collapsed in one giant landslide. There's no terraces on that side. It just flat collapsed and down it went. No gracefulness about it at all. So two different types of collapse on the walls of this crater. The lunar soil, the surface is not strong enough to support massive 5-10 kilometer high walls. So once the crater is formed, gravity takes over and they crumble and collapse inward, creating these terraces on large craters. Smaller craters, like for instance, like the one immediately off to the left of Aristoteles, a very simple bowl-shaped crater. If they're smaller, there is enough strength to maintain the physical shape of the crater. But if they're larger, complex craters, larger than about 15 kilometers,
can you connect
then they
my
will collapse into these.
Can you
hello?
connect my thing really quick?
Hey, Pran. Well, I'm about 30 seconds from finish if Pran has something to say. Anyway, so these are my lunar areas for this week, the sentimental lunar favorites that people like. And over the next couple of weeks, we'll progressively trudge across the moon and look at other areas. So I hope you got a little bit out of this. And if you do consider getting my new book about the moon. It's got lots more where this came from, and I hope you enjoy it. So I'll see you all next week.
Yeah. Now, there is a question here. Natalie Davis Olson said, I'm late. Is this the moon? Yes, Natalie, this is the moon for sure.
Absolutely.
Yeah, Robert Reeves is one of the big experts and one of the finest lunar photographers around. So anyhow, there is a question here from John Ray, and he's watching on Facebook. He wants to know how you feel about what appears to be a future population on the moon for commercial purposes. They could visit your targets, for example. And he thanks you for your presentation. What are your thoughts on that?
Well, it's inevitable. I mean, the development of the New World back in the 1700s was driven in part by the trade, by trading, by commercialism. And well, the Americas wouldn't be here if it wasn't for that driving factor. And you're not going to be able to stop it. There's going to be commercialism on the moon. We're going to find ways of developing its resources to help us on Earth because, let's face it, there's more of us every day and our resources are getting less and less. And we've got to get smart about how to keep this place going. And if the moon can provide those resources, it's going to happen. It's a matter of making it economical enough. Getting to the moon right now is viciously expensive. But 100 years from now, transportation to the moon could very well be affordable, feasible, cheap. We just don't know. 100 years ago, we would think that flying across the Pacific Ocean was a possibility. Well, now we do it routinely, for fun even. This will happen on the moon as well. Whether or not that's a good thing depends upon how good a steward we are of our world and the moon itself. So I hope we take better care of the moon than we've taken care of our own world.
Right. Yes, that's right. We don't want a bunch of more trash out there, right? Last question about the moon. Natalie Davis Olson watching on Facebook. Natalie wants to know what your thoughts are on the upcoming South Pole exploration.
Well, I'm excited about this for various reasons, one of which a very good friend of mine is an astronaut that's very much involved in that. And it would, I've assisted him on 3 of his space flights so far. And if he goes to the moon, I have a sneaky feeling I'll have a front row seat of the whole action. So yes, I am very excited about this kind of stuff happening, and I pray that my friend is going to be part of that. But in the meantime, going to the South Pole is, well, the North Pole would work as well, but we're going to the South Pole in this place. Is a necessity because we've got to develop the water resources. If the moon is going to sustain human colonies, if it's going to be a base to further explore the solar system, to leave and go to other worlds, we've got to find a way to efficiently harvest the water ice on the moon and turn it not only into water for human use on the moon, but to create rocket fuel, hydrogen, oxygen, to carry on our explorations further out into the solar system using the moon as a base for that. And this all sounds very science fiction-y, but it's a very practical plan. Once the transportation of getting to the moon is the expense of it is no longer an issue. Hopefully, Elon will get his Starship percolating here in the next few years, and it will become an economical means of getting to the moon, just like his Falcon is an incredibly efficient and inexpensive way to put satellites in the low Earth orbit. I'm praying that the super heavy Starship will follow the same kind of technological lead and allow us cheap, routine, easy access to the moon. Of course, it's got to be perfected first. It's had one flight that didn't quite go well, but then again, look at Elon's initial flights with the Falcons. It's a learning process, and they mastered it. They made it work extremely well. I have confidence that given time, it will become the taxi that will be taking us to the moon on a routine basis.
I have a feeling it will be. So Elon's been able to work out a lot of these things and really learn from, the crashes and explosions and stuff, because that's kind of what it takes to get it right. So all right, well, thank you, Robert. We are going to transition to Pranvera Cassini for a moment. Pranvera is from Kosovo. She is currently living in the United States. She's getting her, I think she's studying for her PhD, and she is fascinated by asteroids. I think she just got back from a conference. Do you want to tell us about it, Pranvera?
Hey Scott, nice seeing you and nice seeing everybody. I've enjoyed hearing your talks. I was having dinner and kind of overhearing all of your talks. Today was a significant moment for me. It was the first time ever that I shared my actual research in a conference. This was the Bay Area Planetary Conference that was hosted by my department in Santa Cruz. And all the universities here, UC Berkeley, Stanford, UC Santa Cruz, UCLA, all the Californian universities kind of came together, and there were participants from all these different schools, and also from SETI Institute and NASA Ames, who happened to be in this area. And it was really amazing because there were talks on all kinds of planetary science, starting from Jupiter and then Saturn rings and Ryugu samples, asteroids, James Webb Telescope, and it was really nice. It was a full day of talks, and each talk lasted about 15 minutes. I personally didn't have a talk, but I had a poster, a conference poster, where I presented my current research work that it's focused on understanding hydrated asteroids and what's controlling the spectral classifications and spectral absorption band depths exactly. These are measurements and meteorites. We have been working with my advisors, Dr. Miriam Tellis, Andy Rifkin, and Dr. Carl Hibbets from Maryland. So we have been testing out meteorite samples, mixing them with different ammoniated salts and organic compounds, and trying to make their spectra look like these hydrated asteroids. And we're trying to figure out what's controlling exactly, especially the area, the region around 3 micron, 3.2 micron band depth. And it's been amazing because I've been working in this project for like several months and not being able to talk about it publicly, like not being able to share about it publicly on social media or anything. It was kind of very immense to keep all of it away. But today was the day where actually could present it at the conference and the poster, talk about it. And I will be posting the actual poster on social media now. And it was really, really nice. I have never done research before. I did my master's and I did my bachelor's, but it didn't really involve any actual lab research. And this has been amazing. So this was my first PhD project. This has been going on for several months. This is just my second year of PhD, and I still have more projects that I'll be working on, mostly focused on minor planets, understanding asteroids and comets. I believe those are objects in the space that they don't probably get enough attention because we all look at like gigantic planets and their moons, but we don't look at the very dark, mysterious stuff that it's just wandering around in our solar system. And I'm very curious to understand what's going on with these planets, with these minor planets, and what's happening in their surfaces, and trying to understand their formation histories. And I'm just going to say that it was such an exciting day for me. And I'm glad to be here. And hopefully I will be back here again next week with you, Scott.
Okay.
So, thank you.
Thanks for the special update. That's wonderful. Okay. Any of you that are really interested in asteroids, you can follow up with Pram Vera on Facebook. I'm sure she would love to hear your thoughts on certainly water, these tiny water worlds, because if they're hydrated, maybe that's a place where we could harvest our water as we're trying to go through the solar system. Thanks very much, Pram Vera.
Absolutely.
Take care. Okay, up next is Steve Siedentop. Steve is an astrophotographer, but he's a lot more than that. He is very involved in astronomy outreach, and he is, having met him in person, I can tell you he's extremely enthusiastic, guy with a ton of energy, and is somebody that's, can sustain, the important work that you have to do in outreach. You can't just kind of jump in and jump out of it. You could, but if you really want to make an impact like Steve has, you need to stay in. And so, Steve, thanks for coming on to Global Star Party. I know that you have a big star party of your own that you're putting on.
Thank you, Scott. I will share my screen. I've got a PowerPoint presentation. I'll try not to make it too painful. I don't know about you, but I do PowerPoints for a living. So let me know if you can see my screen.
I think there is something called death by PowerPoint. So
indeed, and death by 1,000 PowerPoints. Okay, so my name is Steve Siedentop, and I am currently serving as the director for Charlie Elliott Astronomy, and we are a chapter of the Atlanta Astronomy Club. We meet once a month on the east side of Atlanta at a place called Charlie Elliott Wildlife Management Area. And we have some land out there and an observatory with a few concrete pads. We have a conference center where we meet, and we usually have a presentation by a working astronomer or a PhD candidate. We are blessed to have both Georgia Tech and Georgia State within driving distance of Charlie Elliott Astronomy, and we do a lot of work with the astrophysics department at Georgia State. Dr. Misty Pence is always very helpful and very kind in sending us speakers. We're kind of the proving ground for PhD candidates who want some practice defending their thesis and talking about their information. So one of the things that we put on every year is the Peach State Stargaze, and my wife affectionately refers to it as Astro Dork Week, and so it's the week-long event, and it takes place at Deer Lake Astronomy Village, which is a dark sky community east of Atlanta. The Atlanta Astronomy Club and Deer Lake Astronomy Village host the Peach State Stargaze, and the Star Party has taken place every year since 1994. Even during COVID in 2020, when it was officially canceled, about 50 people still showed up. And fortunately, the field was big enough that we were able to stay far enough away from each other. But we still, the Star Party sort of self-organized with kind of the core group from people in the club and people close in the area. The Atlanta Astronomy Club was founded in 1947, and the Star Party is held on Greer's Field at Deer Lake Astronomy Village. So what's Greer's Field? So you might have heard of Greer's Almanac. Greer's Field is the main field where we set up camp. It's named after an astronomer named Robert Greer, born in 1780, died in 1848. And he published notable eclipse calculations and ephemerides. He is the founder of Greer's Almanac, and actually his astronomical calculations are what led to the publishing of the almanac, and it is still published annually today, with about 2 million copies a year sold. And the chimney of his home can actually still be seen at the entrance to Greer's Field. So as you're driving through the stand of trees, if you look to the left before you see the sign that says 5 miles per hour, no dust, You look to the left, you'll see a chimney that's a few hundred, close to 200, 250 years old, if my math is right. It's been a long day, but it's kind of cool to know that that's there. So if you're wondering where it is, there are two stars on this map here. So we have Atlanta and we have Augusta. And contrary to popular belief, there's a lot more in Georgia than Atlanta and Augusta. The Masters and the Falcons. But about halfway between, off of I-20, is Deer Lake Astronomy Village, and it's placed conveniently close enough to things like Walmart and restaurants. So, if you've been to the Nebraska Star Party, if you forget something, it is an all-day event because it is out in the middle of nowhere, and you are going to drive. Right. My son Connor and I went to the Nebraska Star Party this year, and I think the second night there, we had some really awful thunderstorms roll through, and they have this huge tent set up, circus tent type thing set up, where everybody congregates and eats. Well, the storm blew it away, and it also blew away our canopy. So we ended up driving the 150 some odd miles to North Platte to go buy the last remaining canopy, because everybody else that had canopies was also there buying canopies. So we cleaned out Walmart. We have a new mall, and I use air quotes around that, fairly close to Deer Lake Astronomy Village. It's a Family Dollar and a Dollar General store across the street from each other, so the locals refer to it as the mall. If you forget something, it's probably a 20-minute drive. You forget a pillow, forget a blanket, forget stuff like that, or if you want to go grocery shopping, they have the bare essentials. And if you notice, there's another star down south and west of the pin I dropped. So that is Charlie Elliott Wildlife Management Area. And that's where the Charlie Elliott chapter meets every month. And if you are in the general vicinity of the Atlanta or the Augusta area, our meetings are open to the public. They're free. You don't have to have a telescope. We love it when you ask to use ours, so feel free to join us sometime. So why would you bother to attend a star party? So this picture was taken a few years ago, and I think I was probably the first person in the club to buy an Explore Scientific telescope, and I liked it, and I liked the way the company treated me, so I told everybody that would listen to me about it, and so we kind of became the Explore Scientific Astronomy Club. But this is one of the Peach State Stargazes, and this is Imager Row. So there is something about gathering with people of like minds and interests, and a synergy almost emerges that becomes, it turns into something that becomes greater than the sum of the parts. You can learn more in one night at an event like this than you will in a year of immersing yourself in cloudy nights and any other astronomy forums you might be able to find. And I say that from experience, because I languished for a year by myself, and then I went to a Charlie Elliott astronomy meeting, and there were some very kind people out there that filled in a lot of gaps for me. But if you've never been to a star party, there's a lot of them going on. Take a trip. You will not regret it. And you also get to look at big telescopes. This is a folded refractor. This was taken at one of the Peach State Stargazes several years ago when Damian Peach attended. And this was pretty impressive to look through. The guy built it himself. And that mount is actually the machine gun mount from a submarine that was being scrapped, from a Navy submarine that was being scrapped. So that is quite a piece of equipment.
Steve, are you able to bring that up into presentation mode so we can see that a little bit bigger?
Oh, can you not see it? I'm sorry, am I sharing the wrong screen? Let's try this again.
Sure. That's bigger. PowerPoint makes it tricky sometimes.
PowerPoint does. So here's what I will do.
No one was complaining, but I want to see that mount.
Yeah, yeah, definitely. No problem. So let me, PowerPoint wants to, let me switch screens and then reshare. We'll try this again. It's still, okay, still didn't like it. One more time. All right, can you see it?
Yes.
Okay, very good. Apologies for that. So, yeah, this is a folded refractor, sliding counterweights. Not that I think that, you know, a Nagler 31 is going to change the balance too much on it, but it was a really cool telescope. Jupiter was up, if I recall. Or actually, I think it was Saturn that we got to look at through that telescope. But as you can see, there are RVs in the background. So we've got RV hookups, we've got real bathrooms, we've got Wi-Fi, hot showers, all of the accoutrements of civilization. So at star parties, there's always the imagers and the observers. And I kind of cycle between imaging and observing. I find observing to be very therapeutic, especially when my imaging equipment is not working the way I want it to, because, you know, that just kind of happens. So we have something called, that's affectionately referred to as imager row. And it's a row of concrete pads and electrical outlets where the imagers can kind of keep to themselves. And then we have Dobb Hill, which is on the other side of the road, the other side of the drive that separates the two parts of the field, where the visual observers can set up and have some have some separation between the equipment and the light and the stuff that visual observers try to avoid. So clouds happen. This is the Cloud Witch. We set this up every year. Sometimes, some years it works, some years it doesn't. But in Georgia, as a general rule, October is a fantastic month for weather. It's usually dry. It's not super hot and super muggy and humid in the daytime, and it's not too cold at night. But on the nights that we do have clouds, we have a pavilion, and we set up a projector, and we'll show a movie of some sort. Sometimes we'll play Armageddon and make fun of Bruce Willis and all the inaccuracies in the movie. But it's always a good time. And you know, it is a star party. It's a party, so you can spend time connecting with old friends and making new ones. And that's always very enjoyable. And I find that connection something that I need on a pretty regular basis. So this is a shot on the field from a friend of mine. This was his very high-tech ventilation system for his tent. And we do have the basics of civilization. So, you know, we have concessions out there. We have hot showers. We have Wi-Fi, internet, RV hookups, electricity, pavilion, picnic tables, a grill. If you are not the camping type, however, if camping is not your jam, there are some good hotels within about a 30-minute drive of the field, so you can and people do set up their stuff, park in the we call it the off-site parking. It's an area where you can park and come in after dark and leave, you know, before rise, and not upset everybody with your headlights. So even if camping is not your thing, you could still join us at the Star Party and enjoy yourself. So that is what I have. I have a few links here, the Peach State Stargaze, and Scott, I'll be happy to send these to you if you if
Send them to
anybody
me in
has
chat
any
here,
questions.
and I'll put them up on the live chat.
Will do.
All right.
Will do. Okay.
All
Very
right.
good. Anybody have any questions, concerns, emotional outbursts? It's okay.
Let's see. They were just talking about the mount, but I think it's great that I think this is maybe only the second time that Peach State has been really discussed on Global Star Party. So I really appreciate that.
Well, thank you for letting me come and talk about it. I really appreciate it. Atlanta Hobby is a supporter of the Peach State Stargaze and a supporter of the Atlanta Astronomy Club. And if you're in the Atlanta area, they are a stocking Explorer Scientific dealer. They sell. We actually have telescopes in Atlanta again.
Awesome.
If you remember years ago, we had a store called Camerabug, and Camerabug closed. But yeah, Camerabug. Worked pretty closely with them for a while. But yeah, if you're in the general area, check out Atlanta Hobby. Talk to Cliff. He's a good guy, and he'll take care of you.
Wonderful. Thanks so much. All right. So we are nearing the end. Sadly, we're nearing the end of the Global Star Party, 131st Global Star Party. But we have our very special presenter, John Schwartz. He's an artist, an astronomer extraordinaire. But I think tonight he wants to talk about what could be the ultimate way to Star Party.
Hello, everybody.
Hello. What
I'm in the cosmos.
An incredible starburst behind you.
Man, I will tell you, these meteor showers have been getting to me lately. It was so beautiful at the Star Party this week. The marine layer came all the way into Southern California. And basically, our summit was just above the cloud cover, which means we have the most incredible, viewing conditions possible. We've had insane deep sky, really nice transparency, and there was a lot of people there, and we were breaking out all the stops to show them the universe. So we were doing, first and foremost, we must never forget that we are visual astronomers. The only way to get photons is through the eyepiece. And they do affect you, trust me. I've been seeing stars for days, ever since I stayed up for 3 days straight. But we had, one of those great nights, and everybody was there. We had 4 giant Dobsonians, the Fabulous Four. We had Mirko, the king, of course, with the 32-inch slipstream telescope. Then second is mine. It's a 28-inch. And then I sold one of my scopes to Bjorn, and he bought the 24-inch. And then Jerry was there with the 22. So when you can only imagine when the public comes up there and like, what is going on this weekend? I always tell them, I'm looking for aliens. Especially after Mexico, they released those pictures of those aliens. And I just don't want to mind meld with one of those things, because if you remember Independence Day, that can give you an excruciating headache. Those whining hiss.
Right.
You remember, but that's scary. I'd be careful with those aliens.
Is that the reason why my ears are ringing?
That is it.
That's it.
It's not tinnitus.
They're
trying
it's
to
not
communicate.
It's aliens.
They want us to be green, a green universe. No atomic waste. That's what they're telling me.
Oh man.
That's why they tried to tell Tesla to create this energy. They were communicating. Some say, but
Yes.
I think he was just a gifted person, but it sure would be neat to know. So it was a real incredible, weekend. I would have liked to have slept a little more, but I brought my little buddy Boss, and you know what he does at night? He's sleeping, and I was viewing and showing people. So it was really a great night to share the sky with new people that came up that have never seen anything through a telescope. And I might have blown their mind with all the different tools I use. So we were using visual astronomy with many various giant telescopes and eyepieces. Comparisons, we were doing comparisons.
Nice.
Then we shifted to cell phone astronomy.
Uh-oh.
So the question is, cell phones are extremely good. What don't we do on a cell phone? I mean, I'm telling you, I do so many things on my cell phone. It's kind of scary, but we were taking galaxy photos with a cell phone. If you can believe this, it really did happen.
Galaxy shots.
Galaxy shots.
I have seen some galaxy images. Mike Wiesner's presented some stuff like that to us. There are a couple of apps out there which are very good for doing this kind of thing. Do you guys use apps or?
Yes,
oh,
we do.
Okay.
Sure. And I'll tell you, if you have a Samsung phone, it has the ability to paint. So you can actually paint in some detail if you're not happy with it and rework your images on the fly, like I did at Mount Wilson for my friend. And at the end of the evening, when you're at Mount Wilson, that's a giant telescope, and there's a huge line. So you're all waiting to get, and there's a lot of older people and they get tired. It's really late. I go to bed at 7 o'clock sometimes. I'm so tired. But, standing up and waiting to go view it, it becomes kind of tedious, and tiring. So what I wanted to do was show them how amazing. I would take pictures with the cell phone. Then I would work with my free program to process. So Photoshop Express, #1, great program. Yep. It has all the levels. It has contrast filters. I mean, it does text. It does borders. It does a whole bunch of great stuff. I only use some of them because, it's limited for astronomy application. You can do stuff with regular photos. You can create other stuff, and it's amazing.
And it's free?
Free app. It's called Photoshop Express. Wow. Even if you want to retouch your photos at home, I've remastered some old photos that were Polaroid. Remember the Polaroid? You take a picture and it comes out. You have to wait for it to dry or cool, whatever it does, and then the picture appears. And so you have a portable, you don't have to send it out to develop it. And that was like the first, cameras. But so anyway, we really killed it. We had a great time. So let me get started and show you guys. I don't want to bore you too much with my talks. So let me get here. I'm going to arrange these in proper order. So now I do them. I have a GSP files that I create albums, and each GSP I have a record of, and I get to go back and look at some of the stuff I've presented, and it's a lot of fun. I mean, I have really enjoyed this. I couldn't wait to share this stuff with you guys, because you can't imagine if you go to a star party, when you see that big telescope, the first thing you're going to do is go to that telescope. And there was 4 of us. So it was one of the best nights for public work. And we showed people things that they've never even heard of before.
Oh, yeah.
And
couldn't possibly see through a smaller scope, right?
Well, the seeing was extremely good. So everybody was getting absolutely amazing views. I mean, there wasn't a bad view. The only bad view was the light pollution. Some of these people come up with their white lights, and you have to teach them the etiquette. But anyway, I never got to show you my plaque. So this is me at Wilson, and this is the Reflector magazine, and it shows that I'd won the contest and gives a little description of my thing. So it was nice to see that in the magazine. Very rewarding for me.
Great.
There's the plaque, the one I couldn't get focused. Look at what a beautiful plaque.
Oh, yeah. Yeah,
and
the Astronomical League, I have to say, they always do a great job with their presentations and their plaques. And I mentioned earlier in the program about all the award programs that they have, and this is just one of them.
I mean, there are some awards. There's some very, very dedicated people that have Master Observing Awards, Master Outreach Awards, and, just incredible venues and different things their goals. It takes a lot of work to achieve that level of, to get a plaque for some of these, like the Horkheimer Award. I mean, I'm not nearly ready for one of those. I would like to try for some outreach awards, because that is my mission, is to share my views with the public. And that's what I'm there for. A lot of people, they don't like to share, and I tell them, hey, come over here. Let me show you guys what I got. It's very rewarding. And the Astronomical League has actually brought my viewing sessions to a newer level. There's so many different people in there, and so much knowledge and information that'll make you almost a professional astronomer. But we're still amateurs, someday maybe we can graduate. I might join the Space Force again. Did the Marine Corps. Maybe I'm not too old.
Maybe not.
It's a great thing. That's my little buddy again. He was up there with me. Such a great guy. He just lets me do my thing. Doesn't bother me at all. I love him dearly. So here it is. These are some of the views. So what you see here is at Mount Pinos. This is our viewing location, and we're all set up. It's a very strenuous. I can tell you this. You think of astronomy as a bunch of scientific people and guys that are very technical, and they have, surgical type instruments, the refractors, and, a lot of astrophotographers. There's just amazing variety of people up there. And we all get along because, they're saying, well, look at my astro image. And I'm like, hey, man, check out the view through my scope. or look at my drawing, or check out this cell phone snapshot of NGC 253. Mind blowing. And I couldn't have done it without that program, Photoshop Express.
Yeah.
Free program.
But you forgot to mention something here, John.
What did I do?
That you forgot to mention is how friendly amateur astronomers are.
That's the thing. They are the nicest people. They just love the companionship with the public, and showing them, and the interest, and it wouldn't be fun at all if people didn't come up. And
oh yeah, you're right.
The caveat is always sharing your image and enriching someone's life. Having somebody see both stars in a ring nebula, that was like one of maybe 3 times in my life I've seen it. And I showed this mom and 2 boys, and I was doing photo clinics, how to take pictures of the sky with your cell phone, and all these people are taking pictures. And this one kid runs up to me and goes, sir, I took the best picture of my life. Look at, and I was like blown away. I was awesome. It made me feel so good.
Yeah.
And, that these people are that interested in they were getting results. So great time. Here, I wanted to say, it is not for the weak. These telescopes are 300 to 400 pounds. The amount of work setting up and tearing down. And then, we always have technical difficulties where you get these things that happen. I'm not sure if it's because all the ZWO, the air modules, and there's so many different signals going on up there that we're wireless, that our signals get crossed, and our scope will just start slewing on its own.
That does happen.
but I could tell you, I've seen a lot of these guys with these big dobs after that weekend. They were crippled putting that stuff in, and thank God I work out, and I'm just driven to do this hobby. So it's very tough on you, staying up late. I mean, you wouldn't think, but you got to be.
Astronomers do.
Yeah, it's quite an amazing. Not only are you using your mind and all your facilities, your vision, but you have to have a physical prowess. That ladder you see is like an 8-foot ladder. Now I put wheels on it because by the end of the night lifting it, I couldn't even lift it anymore. I'd feel like I was going to collapse. So I put the wheels and I just rolled it around. So visual astronomy with the big Dob, it can get to you after a while. So I was like knotting up. We stayed up all night until daylight. And then I'm going to show you in a minute. I don't want to ruin it too quick. Here's my 28. Look at that beautiful Dob. And it's all go-to. It's just very elegant. And to look through that eyepiece and see that, we were comparing your 98 millimeters and the ethos. And boy, those are the two eyepieces we really use most is Explore Scientific and Ethos, an occasional Nikon Nav or a Pentax. But, the wide field is very captivating. It creates like a spacewalk effect. And when you see the stars that sharp to the edge, you can't really see the whole field with your pupil. You can see the center, but when you scan around and use your averted vision, it just comes alive. There's depth to it. It was amazing. We even were using bino viewers. We were using doing filter comparisons on planetary nebula in the Orion Nebula, which was the most amazing views we had this weekend. Fantastic. That's the daytime. Again, here's Mount Pino. So you can see we took up about a third of the parking lot.
Now, why do you, I know why I would do it, but why do you think most of the people put a carpet down or something?
If you're an astronomer and in the dark, you drop a lot of things or stuff just falls off. Like you forget to tighten your bolt on your eyepiece. What was that? Oh, that's going to leave a mark, a $700 mark. And then my tail rad fell off because I didn't have it screwed in and it shattered. Luckily, I carry about 5 or 6 of them with me. That's the other thing. You always want to have some, extra critical items because if you don't, you're going to be sorry. You'll be kiboshed for your viewing session. But again, I want to tell you, there were so many great people there that they just come in. Bjorn couldn't get a scope working. Don Penzak came in. Mike Garrett, my friend Mike and Mirko, everybody helped everyone. And he was able to get it up and running. And I had some issues, but the funniest thing is I told Mirko one time, we get up there and I go, Mirko, don't you have a carpet? So I don't need a carpet. I go, well, what if something falls? I mean, or you have an accident? I don't have accidents. Okay, well, 2 minutes later, Mirko goes, right? Oh no! I go, what did you do? He goes, dude, look at. I look at it, the 30 millimeter Explore Scientific, the feather touch focuser and the paracore. The whole train fell off.
Oh my!
Because the 3 set screws on the feather touch focuser, they come undone because when you're driving these scopes in a trailer, there's some serious vibration. So the loose screws. He said
that's one of the things you need to check when you're
always
going
check
to
your
these
screws.
star parties.
You find a screw,
all those screws. Yeah.
Take them with you because later you'll know what they were. And Mirko showed me on his upper cage. You see on the cage here how they have the spider mounts, right? And in between ours, because they're real heavy, they have a square tube for extra support. 3 of the 4 were missing the screws. They were gone. And I go, Mirko, those. So I told him, if you ever need parts, a great place is McMaster Car. They are like they got everything you could ever need, and a lot of it works well with telescopes.
They are the
So-
astronomer's friend. Yes.
They are great. So this is Bjorn's scope, the 24, which I
Very nice.
sold to him. And then that's my 28 right there. Mirko's 32-inch. Look at that thing,
That
the
monster.
stub.
Oh,
It's
yeah.
an F3, and it is stunning how sharp the mirror is. It's really a fine piece of work. Michael Lockwood. Here's a fella that's an astrophotographer. So the funniest thing was we're trying to get close to each other. And, the astrophotographers, they're in their motorhome chilling. They're just running their, script. They set up, okay, let's take for an hour, 30-second exposures at, whatever. They pre-program the script, and then it just automatically does it for you.
Yeah.
So, and he was getting some great images. That's a Takahashi.
That's awesome. Yeah.
And then,
having a trailer like that just makes it, and it's like you have your, your warm room.
Oh, yeah. You need it. You do need it. It doubles as a transport for instrumentation. So, I like to carry several scopes with me at all times, just because I have scopitis, So we start small, and when somebody hurts me with a better, bigger scope, I have to roll out on them, So maybe one day I'll be able to kibosh everyone with the 40-inch, but I got a quote for one. We won't be getting that one. Just a mirror. It's more than like a mobile home, believe it or not. That told me this is just sunset. We're all waiting here. So you can see everyone. That's Mirko. He had his girlfriend's dog, sweet puppy. Boss, I didn't let him get too close because she's a big girl. I didn't want her to hurt him. And that's Jerry in the background. Now, Jerry is an amazing astronomer. He has incredible. He's like me. He has probably 20 scopes. And this is a Star Master with a Lockwood. So Mirko and him had Lockwood mirrors, and Bjorn and I had Kennedy mirrors. So we were Team Kennedy, and that's me, of course. I look a little weathered. I'd been up a while. I'm still looking okay, the guns, but
you're still standing. So
yeah, I mean, you could see my feet. I was like, my legs were killing me. That's why this night I chose to use the Malin cam. So
okay.
Mirko's telling me, don't do it. It's too much. I had to take off my focuser knob and mount all these gears and then put on a motorized wireless unit, Feather Touch. I think I have 12 or 15 Feather Touch focusers. 4 of them are wireless. I like the way they sparkle on the scope in the night.
Mm-hmm.
Plus, they work very well. There's my baby right there. Just a great scope. This was the first one that Tom ever made. Here, let me show you my Feather Touch. See the big knob?
Oh, yeah.
And I have the cover so the gnats don't get in there.
Mm-hmm.
But, converting that and then doing all the wiring, I had all this stuff packed in about 10 giant cases. I had to go through every case, but I did it. I got it done. And I succeeded. And I sat in a chair, and my go-tos were dead on because I was using the camera to do my star alignment, which is a lot easier looking at a TV screen than going up that ladder, going down, going up, going down. I mean, if you don't have your Telrad by nightfall, the key is you want to have your scope set up and collimated first and foremost. Then you've got to get your Telrad aligned and your guide scope. I use a 5-inch guide scope on the back, so I have to get them all aligned. So if you have a distant tree or something that you can do that, I would recommend highly doing it, because if you're trying to get your show up and running and people are waiting, there's a lot of pressure there. For me, I can't stand when I can't get things in working. When you're trying to do it too hard, that's when you get stricken with it. Just, you can't find it. You can't get it in the eyepiece. It's just the craziest thing.
Yeah.
But if
I
you
think a lot of astronomy outreach people can relate to that. I think it's always best to have, another scope that can set up quickly, and doesn't require any special, doesn't have any electronics, nothing, and people can start looking right away, because they'll the super eager people that will come out from the public that have just been dying to look through a telescope. They'll just want to get their eye right on the eyepiece immediately, so.
Oh yeah, they're so enthused.
Yeah. And if you're
Now
doing outreach with a telescope that requires some setup, and you don't always have this luxury, but it's best to arrive real early, and get everything all dialed in, and then, and then you can patiently wait while a crowd comes up. So.
For sure. I agree. This was, I sat down that night and I wanted to see what M74, because in the eyepiece, it's very faint. Even we're Bortle 3. Even, with a 28-inch or a 32, it just doesn't show you like this. And for me, honestly, it's good to do all of them, really, because they're tools of the trade. Each one will show you something different. The astrophotography is a passionate, it's similar to my art in the processing aspect. And when you can create some of these pictures, and with ZWO, it's easy. It's easy to do. There's people that have only been doing it a couple of years, and they showed me their image. I was blown away. So I wanted to sit down and see, because I drew this object, and I went to 3 of the objects that I drew, and the Malencam revealed that detail incredibly well. For instance, the One Galaxy NGC 7753 in Pegasus, which is 270 million light years away. We're all looking at it in the big dogs, and it really, it's nothing like what the Malencam is going to show you. And if you do use any kind of a Malencam or any kind of imaging, you really got to control your light pollution. And I had a couple fouls with some serious people. They're like, John, you know better. I was just wrecked. I couldn't stand up anymore. I mean, my legs cramped up, because Bjorn and I, we don't go to bed. He's like one of the only few, and Andrew Clark, the artist, he'll stay up all night. We're all nighters, but a lot of guys, they go to bed early.
Yeah.
I only get to do this. Yeah, I gotta
That's
go.
When the best observing starts is after midnight. So.
Well, we were observing nebulas and planetary nebulas and Jupiter and Venus. I was viewing NGC 7662 at 7:15 in the morning. How did I do that? With a 28-inch and the Lumicron 03 Gen 3 filter.
Oh, wow. I
was looking at Orion at 7 o'clock, and I could still see the stars of the trapezium. About 6:30, 6:45, you start to lose the nebulosity.
How did the sky look to the naked eye to you during those times? Was it already starting to
It was, the sun was up. The sun was just, when I looked at NGC 7662, this is the greatest thing that, it's, when we went up there this time, we did stuff. It's the proving ground. I mean, we set the bar, and we loved it. We had the greatest experience. Everyone else went to bed. When we told them, yeah, you guys are lying. I got the best view of Venus. I got the best view of the trap stars. When the light comes in, it's light. Like when you look at the planets at dusk or dawn, that's the best time, because when you have the contrast.
Time, I mean, the sky's really still at that time, so.
And, with the night sky in a bright star, because there's so much difference between the two, that they just don't pop as good unless you have perfect seeing. But I'll tell you something, the trap stars were so separated. I've never seen them that separated before. I had these in order. I don't know what I did, but let's keep going. Here's a view looking up my ladder. It's a daunting task. Do you want to go up 118 inches in the middle of the night?
Looks like the ladder to the cosmos. It's really cool.
Yeah, this is the Milky Way shot at Pinos. You can see my eyepiece right there.
Yep.
And that ladder, I padded each step. It's a tall man ladder. They're 8-inch rungs, and it's designed specifically for astronomy. And it's a fruit picking ladder. It's a tripod, not a four-legged ladder. And that's another thing. Be very careful if you have a long focal length telescope with a four-legged ladder, because I've seen a lot of bad accidents. You lean over just a little too far, and next thing you know, wow, what happened? And then you hit the ground. Then you know what happened. It's very painful. Look at this one. Look at that Milky Way, man. I mean, it was such a great night. It was so dark because all the clouds covered all the coastal valleys, Bakersfield, Fresno, San Fernando Valley, Palmdale, Malibu, LA. I mean, you know, that's what really bothers me about this whole thing is we're losing our skies. We're losing them bad because of light pollution. And we really got to do something about it, because in 10, 15 years, I don't even know if I'll be able to see stars. You know, it's really, but this night, those clouds covered all that stuff. It was like the universe was giving us a gift to share. And there were so many people that we were sharing with, and they saw everything we were doing. It was absolutely amazing. This is M33 through a cell phone, folks, through a cell phone. Look at, it was unproven ground to see if we could do a galaxy, the very hardest thing. This is like a 15-second exposure with the speed and the ISO set very high, so you can get, you know, the reach. But I mean, for a cell phone, are you kidding me? You know, you don't even see this with the 60-inch or like 100-inch. Like, I mean, well, you probably would in a dark sky. There's my drawing of M33, which went through many different renditions to get there. What was ironic is I had completed this, and then I wanted to see on the cell phone. And this shot is actually my friend shot, Wayne. And I go, would you try M33? And he did. And look, it's better than my drawing. Well, maybe not, but this is the one that was incredible too. 3338, you know, you look through the Mallancam.
Yeah, you can see the bar in it. That's cool.
Yeah. I mean, visually, this just looks like a little fuzzy spot in the 28. I mean, so now I'm using my Mallancam to take my images even further, because, you know, the whole reason is when you do your hobby or something, or you go to an amusement park, where are you going to go on the merry-go-round, or are you going to go on the giant coaster, right? Or free fall? I mean, you know, it's just, you always want to get the best experience, you know, and this gives it to you because you're really seeing stuff, you know, and you don't want to forget where you came from. Photons and visual astronomy is so important that you do that first and foremost.
Sure.
Or at least enjoy doing it. You know, I do many. I'm trying to get the night vision set up. Hopefully I can work something out with David Nagler and get myself one of those for outreach purposes. Then we have
the image intensifying eyepiece you're talking about?
Yes. Yep.
Yeah, I've used one on a big telescope, and I can say it's very impressive.
It's grainy, you know. The astrophotographers will always bag
but what
on
you can see is incredible, and you know, it looks real time when you're looking through the eyepiece. I mean, you bump the telescope, you can see it jiggle.
How about star hopping? Let's go galaxy hopping.
All right. Yeah, that's right.
So this is cool. Somehow my order got mixed up. This was the rocket launch. Of course, we were treated to a rocket launch from Vandenberg Air Force Base.
Oh yeah.
You know, like
was in the Grand Canyon and got this beautiful display. What it looked like a comet, you know,
Wait till you see my other one. This is
okay.
done with my cell phone. So this is, it just came up. This is, Vandenberg's not far, you know, and the flight path is similar, right over the mountain, sort of towards the, look at the separation. Look at the, there's
cool.
the rocket. I got the few, the stage. Look at this. It's over processed. I'm sorry. I just wanted to enhance it.
Yeah.
I haven't. This is, look at the separation.
That's cool.
Okay. I just thought I'd throw it in there. So here is M74 taking a picture of the screen. You know, it's very lines. It's not, you know, like a high definition 4K monitor. This is a Spico color monitor for security cameras, but it's a very good one because of the adjust. But look at what you could see. You'll never see that in the eyepiece. There's my drawing. I think, you know, I love those little crown things that go on top. I mean, that was so impressive to see. I showed you this last time. I'm going to move it forward. This is it through the cell phone. So that was the test. I couldn't believe it. I've got 3 ways I looked at it in 3 different platforms. And then, of course, if you astrophoto this, you know what happens. It's going to show you the most.
Yeah.
But come on, a cell phone. Can you believe it? Look at. I mean, there's some detail.
You used your telescope in 3 different ways. This is all in one night, correct?
3 nights.
3 nights.
But we would go back and forth. I only did Malincam one night because it is hard on, you know, the astronomers. I try to control my light, but when I'm just staring at the screen, I'm mesmerized, you know, and they're like, John, snap out of it. Cover your light. Oh, sorry. I have also video visors, Vizio, and I put them on, and I have a wireless transmitter that transmits. So I put the transmitter on the scope because I have a power for 3 items. So I can power my camera, my focuser, and the transmitter. So it plugs in the transmitter, transmits your signal up to 1,000 feet or 100 feet. And I put my visors on, and I'm looking at 51 in my scope, in my visors, wirelessly. I've got my receiver in my pocket, my jacket pocket, with a small little 12-volt, 7-amp-hour battery. And the visors are connected and the receiver are connected. And I'm looking, and I go over to somebody and say, hey, you want to look through my scope? John, it's across the parking lot. I can't do it. No, look. And I take off my visors, and you can't believe it. There's 51. It's another great tool. I didn't bring him this time. This is NGC 253 through my 28-inch with the cell phone. Let's go edge to edge. Look at that. And I have to say, I've done a lot of processing. These require processing. Your images are very faint. There's structure and detail in the brightest parts. This is all extracted. The data is always there. You just have to know how to extract it. And you just play with all your tools in that Photoshop Express and then bounce it back and forth. If you don't like something, you can paint over it, or you can remove reflections and shadows, and you can take out anomalies or bad pixels, or with the healing tool. And, you know, I go back and forth between Samsung and Photoshop Express maybe 5-6 times for my best images, believe it or not. And that will Procreate too. But I mean, when I'm out in the field, I bounce them back and forth. Is that amazing or not?
It is amazing.
Look at the structure. I mean, any astro that would be happy to take a picture that good with a.
Oh, of course.
You know, in my scope, unfortunately, it's beyond edge to edge. The resolution, I only get the core. So you're not going to believe the next one. NGC 891 with a cell phone. You know how hard this object is to even see?
It's faint.
It's faint.
I mean, not a big scope, it's not, but it,
well, yeah, but I mean, look, I got Starbirth, and you can see some H2 regions in there. I know it's blurry. I apologize, but this, I'm not stacking these and using real Photoshop. These are just field. I didn't have time.
Yeah, right.
I just put these together for all of you because I wanted you to see what you can actually do with a cell phone. Even on the moon and the planets in your backyard, you can take amazing shots. Amazing.
Yeah.
And it's so rewarding when you can take a shot and show people and say, hey, look, you took that. Yes. I mean, galaxies, this is new to me. So I'm kind of excited. This was tough. 7814. You're familiar with this? I apologize about, I processed the heck out of it because I'm working in pro mode on my Samsung phone and it has a blue cast. The S23 has a very strong blue signal. So you get things look blue, the brighter stuff, even the galaxies, some of the brighter ones. But in the scope, you can barely see that kind of detail.
Yeah, look at that pencil thin dust lane,
You've seen that one, 7814.
Yeah. Mm-hmm.
I mean, it's a nice target when it opens up and you can see that. And we were seeing it, not like this though. That's the beauty of the Malencam. I mean, it gets you real deep. The stars are bloated and stuff, but the galaxies and nebulosity, even the planetaries were amazing. Look at this. This is NGC 246 in, I think it's Sculptor or I'm not 100%. It's real near there. It's Phi 253. So this is a triple star system. It's also has a mission nebula as well as a planetary. Cell phone snapshot. Some would have never known it. Yeah. I haven't really worked on it that much because I haven't had a lot of time, but S23 eyepiece projection with the 10 ethos.
Fantastic.
Orion, cell phone snapshot. Andrew Clark, iPhone. Andrew Clark, the artist, who I'll be bringing on the show. Look at that.
Yeah.
With a cell phone. Are you kidding me? And that was done with a 14-inch telescope.
That's really impressive. You could do it with a smaller telescope, though.
Any scope, a 60 millimeter refractor, you can do it.
Yeah.
You guys got to practice this. It's so fun. If you have a Galaxy, I know how to use the Galaxy. And there's YouTube tutorials that will help you with this stuff. There's a lot of people. And there's a lot of information out there on how to do this. This was Mercos 32. Look at the depth. Look at that cloud and the way the trapezium. Yeah. So when we were looking in the daytime,
those aren't star trails. Those are diffraction spikes.
Diffraction spikes. They're so bright. It's a 32 inch. It's from his spider. But look at that. It's much deeper. Look at it. Wasn't a great shot. That's Mercos 253 with a DSLR camera. So look at the difference. So this is a step up from your cell phone, but they're basically the same camera.
Yeah.
But this is like a Canon Rebel or a 60DA. And these are old school. Nikon has them. The reason is the DSLR and the new style of cameras that we're using make it so much easier. So ZWO, they're not CCD cameras anymore. They're CMOS.
Yeah. CMOS
so
technology got so good.
Yeah, and they're now coming out with night vision with CMOS. The Opsin is one, and the Aurora from S-Ionics. They're digital night vision, and I've seen some people starting to use the Opsin to get some good galaxy routine. And also, it's color night vision. That's the beauty of it. It's almost there. They're going to need about 5 more years, and you'll be able to plug it in your scope and go live color. This is M22, cell phone snapshot. Notice the stars are red. This is a very old cluster. A lot of those stars are in the later stage of their life. The camera, even in the big scopes, does show you the color. That's the thing you notice in these big scopes. There's color in the stars,
Yeah.
color in the Dumbbell Nebula, color in the Trifid, color in the Lagoon, very faint, but reds and blues. Perseid double cluster. Look at the colors.
Oh yeah.
That's cell phone
Oh,
snapshot.
yeah.
Look at, I mean, come on. Isn't
Yeah,
that
it's like
gorgeous?
diamonds poured out on
Yeah,
black
I mean,
velvet. Yeah, it's really
you know,
nice.
That's one of your great clusters to look at, the double cluster, because they're almost like globs. You wouldn't believe how M11 turned out. This is M11, I believe. Is that crazy?
It's awesome.
Looks like a globular cluster, doesn't it?
Yeah.
Again, look at the color. M11's a beautiful cluster, open. It's an amazing one to see in the eyepiece. This is the trap in the daytime. Look at, I got 1, 2, 3, 4, 5, 6, 7 stars at 7:05 a.m. Cell phone snapshot. Remember Jack Newton? Was you who he called?
Oh
it?
yeah, we show stars in the daytime.
The stars in the Big Dipper. Hey, what are you doing? Well, I'm looking at Mizar.
Yeah.
I heard that.
If you know where these things are, actually, you can impressively find it with scopes like I've found splitting castor in broad daylight, with an 8-inch telescope.
Isn't that amazing? Look at the separation on
But
those.
that's impressive. That is.
The snowball was the most impressive. That Lumicon filter, you want to, when we start getting anxiety, dude, it's getting light.
Yeah.
What are we going to do, man? Get out the O3 filter. I'll show you what we're going to do. We killed it. I did the, in Aquarius, is that the Rosette Nebula? It was daylight. You're not going to see that. Bjorn told me, I go, dude, check this out. So it's such a dense filter. When you look through, it really kills the starlight. And they're like blue. They turn into like blue and they're very dim, but the nebulosity is insane. Perfect for doing daytime viewing. If you stay up all night, you don't have to try to find this stuff. Your computer's still on. You just press go to and you're there. Couldn't see Uranus. I was seeing the most amazing detail on Jupiter. Even the seeing was garbage because it was boiling by then. But with the color, the blue sky, your Jupiter will reveal colors right after the sun goes down a little bit. You don't want it too bright, and same in the morning. It's the best time to see color. Again, because you're not so far apart from dark and light that all the midtones open up and you start to really see some fine detail that you never see. That was the Venus shot, daytime. I mean, that was a pretty good disc. I know it's a little fuzzy.
The universe is still out there, even though it's daytime.
Yeah, it was almost showing some clouds. There's my little buddy again.
Aw.
And I'm closing with him. We want to say good night.
All right.
Thank you, everybody.
Thank
and
you.
I hope you enjoyed this. And
Thank you.
I really hope you get out and try some of this stuff for yourself, because it's amazingly fun and it's really easy to do. You just have to show up and play with it and you'll figure it out. This
Right.
picture I created, my background.
Yeah, that's fun.
I was trying to create the magic quality that this global star party is for me.
Thank you.
It just explodes with amazing people and such great information and people that dedicate so much time for public and to get the word out. And I am so grateful to be a part of this.
Yeah, thank you.
I appreciate it, Scott.
Thank you.
And everybody.
Thank you.
Thanks.
You made
Thank
it
you,
fun.
everybody.
Thank you very much, man. So, all right. Well, I want to thank, if there's some presenters, they're all closed down on the Zoom. side of this, but you know, if you're out there watching right now on YouTube or one of the social media channels, thank you very much for all your great work. We want to extend a special thanks to Dr. Linda Spilker for coming on at the first part of the Global Star Party to talk about the Voyager missions that she is now in charge of. You know, all the presenters really brought their game on for this particular Global Star Party. I think they do every Global Star Party anyways. I have yet to say, no, they didn't really bring their game on this time. They always do, and that makes it special. We will be back next week with the 132nd Global Star Party, so I'll be making announcements on social media. You know, and until that time, you guys keep looking up. Thanks again, and good night.
Thank you, Scott.
Thank you.
Have a great evening.
Take care. All right. All right. And we will, I wish you all a chance to have some clear skies and to keep looking up.
Come one, come all to the Southern Cross Astronomical Society's 2024 Winter Star Party, celebrating 40 years of stargazing, happening from February 5 through the 11th, 2024 on Scout Key in the beautiful Florida Keys. Get away from the cold and adjust your latitude underneath the pristine skies of southern Florida with breathtaking views of Eta Carina, the Jewel Box, the Southern Cross, Centaurus A, and of course, the magnificent Omega Centauri. Tickets will go on sale on or about October 1, 2023 at scaz.org. See you there!
So it's a beautiful sunny day, and we have you know, our refractor out, and I've got my eclipse glasses on, and I've got my safe solar filter. Of course, the eclipse is not here yet, but I wanted to take a few minutes just to show you some things about solar filter safety. The filters that we use is the highest ISO standards, and actually independently tested by us as well. So just to make sure that those standards are met. So if you're going to use a telescope to look at the partial phases, and let me underline partial phases to you. You use eclipse glasses to observe the sun in partial phases when it's in total. If you're going to be on the path of totality, you can take the glasses off, and only during that time can you directly look up at where the sun is, because it's completely blocked out. You'll see the corona, you'll see, you know, lots of really cool effects that they'll leave you speechless. But during all the partial phases, you have to have safe solar filtration. So how do you do it properly? Let me show you. First off, let's show you what you shouldn't do. What you shouldn't do is put on eclipse glasses and look through the telescope that's unfiltered. And I'll show you exactly why here. We're going to point the telescope directly at the sun. And right now, we have sunlight coming right through the eyepiece. You know, I can turn that up a little bit. If you use solar glasses and look right at the filter material, you see it's already burning. It's burning a hole right through the solar filter material. That is how powerful a telescope is. You can now see that there is a hole through there, and that could be your eye. So this is what can happen if you think that you can use eclipse glasses to look through unfiltered telescopes or binoculars. If you do that, the sun's energy is going to burn right through the filter and burn right into your eye. So if you're going to use a telescope or a pair of binoculars to watch the partial phases of a total eclipse, or just to observe the sun to look for sunspots or something like that, make sure that you are using an over-the-lens solar filter that has the proper ISO safety rating and all of that. And so what I'm going to do is I'm going to put this filter on. It's you can see how snugly it's fitting here. This is not about to come off, but you know, if you have a loose fitting filter, use tape. do anything that you can to make sure that the filter's not going to come off. And then the other thing is too is that finder scopes, optical finder scopes are like little telescopes, and they need to be filtered as well. In this case, I just have a red dot finder. There is no magnifying power to it, so I'm not going to use it to sight the sun in. The way I'm going to sight in the sun is literally as I'm going to look down at the shadow and align the scope up so I'm getting the smallest shadow possible of the telescope as it's hitting the ground. And now I can safely look at the sun in comfort and look at sunspots, and if we have partial phases going on in the eclipse, I'll see them all.
Are your eclipse glasses safe for looking at the sun? Let's check to see if your eclipse glasses can handle the heat or if they need to stay inside. First off, never check your eclipse glasses with the sun. That's a good way to injure your eyes. Take your eclipse glasses and find a bright light, like a lamp or a flashlight. Hold your eclipse glasses up to the light and look through them. The light will appear extremely dim or not appear at all when looking through the glasses. For example, you should only be able to see the filament of a light bulb, but not the glow surrounding the bulb. Also, if your eclipse glasses have any marks or scratches on them, don't use them. If you have older eclipse glasses from a previous eclipse, give them the check to make sure they haven't been damaged or scratched. All safe eclipse glasses will meet the ISO 12312-2 standard. It's best to store eclipse glasses in a safe place where they won't become scratched or punctured. Remember, never look at the sun without eclipse glasses or a solar filter. Be safe and happy sun viewing, everyone.